Dr. Chuck is the teacher behind Python for Everybody, one of the most popular Python courses in the world. In this course, he teaches Django, a popular Python web framework.
Hello and welcome to Django for Everybody. One of the things that I like to do at the beginning of each class is sort of say why. Why should you take this class? Why did I make this class? And in particular, why Django? There are some questions like, ooh, why not Flask? And I'll get to that. So I just want to take you back in time a little bit. 3 years ago, I was a happy professor. We were teaching Python for our beginning users in our data mining, and then I thought it was really important to learn a second language, and so I taught PHP for our web dev. I like PHP. It teaches you like how the web really works. I taught SQL, and I loved that, and taught about all the good stuff. And then we taught JavaScript, jQuery, and JSON as well. And I had been building that class literally for 5 years. I had been building the graders for it, the stuff, and one of my metrics as a teacher is how far do my students get at the end of class. And so I look at 15 weeks and what was the last assignment. And then that to me is the way I judge whether or not I've done well or not. And over the years, I try to get the students farther and farther, and I adjust the first part of the class to be more efficient, so that I can be more effective at the end, and so I can put more useful stuff, because there's so much in the beginning classes that is just like, oh, the mechanics of it, and you got to learn the mechanics, and then you can apply those mechanics, but you just can't start off and say, here, cut and paste these 4,000 lines of code. It does you no good whatsoever. So 3 years ago, I had a very well-developed PHP class, and in not too many words, I was told that they didn't want me to teach PHP for web dev anymore because everybody wanted to do Python. And a lot of people were actually doing Flask in some of the more advanced classes, like our mobile application classes. So I was told to switch to Python, sort of told to switch to Flask. I've done Ruby on Rails, I've done PHP, which is pretty raw, I've done Cake PHP, which is a framework. And I've done a lot of programming with and without frameworks, and another teacher taught a class using Flask, and I didn't like how that class turned out. I looked at the end of what they were doing at the very end, and I thought, whoa, that's not very much stuff. But I started with an open mind, and so I actually had a whole year when I was teaching PHP. For one whole year. They let me teach it for the last year. That's also when I developed web applications for everybody, and that's also become a MOOC as well, which I love, and I think a lot of people use it. They use it. It's really a great MOOC. And I'm still convinced that learning more than one language is a good idea. So you might want to take web applications for everybody after you take Django for everybody. So I would go everywhere I would go. I would ask everyone that I would meet, do you use Flask or Django? I mean, luckily, 5 years earlier, there was like 25 choices in Python. But by 3 years ago, it really narrowed down to Flask and Django. There's other cool ones like Sanic that are specialized. But Flask and Django are kind of like the big ones that everybody, not Web2Py, there were so many of them that I'm like, oh man, which one am I going to pick? And that's the problem with PHP frameworks, is there's so many of them. Although Symfony and PHP is kind of winning. So I would ask people, Django or Flask? And people would give me very passionate responses. They would say, Django is the greatest thing ever and Flask is absolute trash. I would go on to the next person. They would say, oh, Django is trash and Flask is awesome. 50% of the time they would love one thing and hate the other one. It was amazing. I really got no trend whatsoever. And so about halfway through that, I'm like, I'm getting no data. I mean, I'm getting half the people love one thing and hate the other thing. And so I changed the question. I stopped asking whether it was Django or Flask, because they were saying, what do you like? I was really asking, what do you like better, not what should I teach? And so I said, look, I can only teach one, Django and Flask, and which would you teach first? And then which would you teach second? What order? And then universally everybody just had to accept the fact that Django was way better, way better to teach as the first class. And so I felt I got really strong data on that, so I picked Django. I wanted to use Django, and in retrospect, it's brilliant, right? I've been working on this Django class for two and a half years now, and each semester I make it better. Each semester I improve the slides, and I do that thing where I try to like compress the beginning and get efficiently done with the beginning part so that I can do better stuff at the end. And I'm really pleased. And so what you're seeing in this Django for Everybody's MOOC is that 2 years of careful engineering of the class. And I'm really proud. You can go to projects.djfree.com and see some of the things that the students have built. I'm amazed at how much they can actually build on their own. And literally, couldn't have done it with PHP, couldn't have done it with Flask. Django is the only way that students would be able to produce complete functioning websites with a real user interface at the end of 15 weeks. And so that to me made Django a great success. And I'll close with, I just got done looking at the most recent Python programmer community survey, and I was surprised to see that the #1 use that they had of Python was web applications, and the #2 use that they had was data applications, which floored me, because I know that Python is great for data applications and it's just super dominant. Part of the reason that it worked out that way is it wasn't like web was twice as much. Python is used for so many things, and so there was a lot of things on the list, and then web just edged out data analysis by a little tiny bit. You can be critical of Python web development, and my answer is, if it's not perfect, it's going to be perfect, because people like to write in Python and they don't want to write in Rust or Elixir or Scala. Those are harder to learn, and honestly, whatever the shortcoming of Python web development, it's going to get fixed. So welcome to Django for Everybody. I really enjoyed, and I've been looking forward to the moment where this was mature enough and well enough developed to become a MOOC, and so here we are, and I'm glad to make your acquaintance. Cheers. Hello, and welcome to our lecture on dynamic web content. It may seem kind of weird to be talking about building web applications, when we start out talking about building web applications, that we're going to talk about protocols and stuff. But in a way, when you are building a web application, if you don't understand the protocol and you just sort of say, I changed this little bit of code and I hit refresh and some magic happened, you really are cheating yourself in terms of becoming a really good web application developer, because ultimately these protocols are what enable web applications. And as you go forward and use frameworks, you don't need to know all these things in detail, but when you debug your applications, you absolutely do. And I don't know if you've had your Firefox console or looked at things and watched. There's so much complexity going on, and when you're using a web application, hopefully everything works and that complexity is hidden from you. So if you have some interest in this and want to go even lower to sort of more of the network protocols, not just the HTTP protocols, I've written a free book on networking called Introduction to Networking, How the Internet Works, that you are welcome. You can buy a print if you want, but it's also completely free, like every book that I write these days. And so if we take a look at what we're going to really be talking about in this lecture and in this web application course, is the different technologies that are used to, in effect, produce a web page, right? So we have a web page over here. You go to URL data.pr4e.org/page1.htm, and here comes a page, and this is like a super simple page. But there are so many technologies, like how browsers work with JavaScript and jQuery and CSS and eventually Vue and things like that. That's a whole set of front-end technologies, and then there's sort of back-end technologies like Django or Flask and databases. And we're gonna learn in this. My focus in this class is less about how to make it all look beautiful, although that's important, and more about how to deal with the back end. So what we're going to see is these technologies that define the look and feel and the interactivity of your web pages, but also then how data and HTML, CSS, and JavaScript are served up by the remote server. And so the internet here is in the middle. The browser is sitting on your laptop or your phone or whatever, and it has all these technologies built into it. It makes requests, and then the server comes back with responses. And so the simplest version of this protocol is that you click on a tag, And when you click on that tag, you get a new web page. Now, if you watch your debugger console, you will see that sometimes it's 120 different request response cycles used to construct the page. But in a sense, they're all the same. Now, as we move to things like HTTP2, there are ways to pull down multiple documents in a single connection, but we'll stick with the old HTTP1 way of thinking about it. In the simplest form, the browser asks for a document and then retrieves the document and then shows the document, and that is the basic request response cycle. So if you look at how this works, that browser is an application running inside your computer on your laptop or your phone. That is a piece of code. And in that, it's got a connection to the screen or the keyboard or the mouse or whatever, and it's watching for events, meaning that you're going to go and you're going to click somewhere, and then this application is going to respond to the events. So in a web page, in the simplest case, you got stuff that you can click on and stuff that you can't. And you go find your way through whatever to click on part of that web page. And that click is intercepted by the application, whether it's Chrome or Firefox or Safari, running on your piece of equipment. And then that application then opens what's called a network socket, a socket across the network to a web server, and sends a request. And that request, as we'll see in a bit, is a specially formatted request. It has a GET command, and then it has the URL that it wants to get from the web server. And then the web server does a bunch of work inside itself, maybe reading disk files and running programs, generating what it is that you want. And then it sends the response back on that same socket connection. So there's like this socket connection through which all of this stuff is viewed. And so the HTML is the kind of the basic thing that comes back. As we go further, we'll see that it's not just HTML that comes back, but other things as well that come back. And so when the browser receives that HTML, then it says, oh, I know what HTML is. I've got this header 1 tag. Here, let me change the color of this thing so you can see it a little better. Yellow is way better. Okay, so when the browser receives this page, it sort of sees it and it looks at it, and then it looks at all the HTML. And so part of this course is to understand the syntax of HTML. That itself is how to build good HTML and CSS and how to make it look beautiful. But ultimately, something in that HTML plus its CSS plus its JavaScript leads to a visual display of the page, and then that's the thing that you see. And so this is the request response cycle. So up next, we're going to talk about what these network sockets are, or the things that fundamentally underlie this request response cycle. Hypertext Transfer Protocol is the protocol that browsers use to talk to servers. Now, we've used it for all kinds of other things because it turns out that it's a super simple and super elegant protocol. Now, this goes to a long time ago. This protocol was invented in 1990, which is like going on 30 years ago. Yeah, going on 30 years ago now, or more. And there were many protocols. You would have one piece of software, and there was server software and client software. You had to match them up, and then you talk to the right port with this server software. And one of the inventions of Tim Berners-Lee and Robert Caillou at CERN was that we came up with this notion of, instead of lots of pieces of software, we would have one piece of software called a web browser, and it would be multi-protocol. And so we have this thing called the URL, or Uniform Resource Locator, and we just sling these around. We just use them. But these things, this was itself an amazing innovation in 1990, because in the old days it'd be like, use this piece of software and talk to this address. So the URL captured three really important, very separate things. The first thing it did is it allowed for multiple protocols. Now, the one that you mostly have seen is HTTP or HTTPS, but that's a protocol. FTP : or mail-to : might be the other ones that you've seen. And then a host, and then a document. And that host is a domain name, which is a nice symbolic way to get a server address. And that eventually resolves to, an IP address like 141.206.14.22 or something. And then the document within that server, and that /page1.htm is the document in the server. And I'm just saying, before 1990, there were many protocols and we did many things. But after 1990, this one protocol, HTTP, found its way into so many awesome solutions that it's by far, other than email, the dominant protocol that we use on the internet. Like I said, it was invented at CERN by Tim Berners-Lee and Robert Caillou to retrieve documents and images. And as soon as they built it, because it was all the other protocols that came, most of the other protocols were kind of complex, because we're computer scientists and we make complex things and we love complex things. And we're very, very good at complex things. But this was, when the web was being built, Tim and Robert were not like, we're going to make the greatest thing ever. We're just going to make a simple thing. So they made a simple thing, but it turned out to be the greatest thing ever, because different engineers would be like, oh, wow, I can use that a little different way. And it was, the grounding of it was super simple. And the basic concept was, you connect to a server, you figure out where it is, you send a single command with a bit of extra data, and then you get back something, a document. It could be an image, it could be data, it could be HTML. And it was really amazing, right? And so the sockets, the underlying sockets, are the things that make the phone call. HTTP is what we do once this phone call has been established. So one of the things that made the internet so successful starting in the 1960s was a radical openness, we're all around the same campfire feeling, very friendly, respectful, that still allowed criticism. There wasn't like one super genius that designed this or one company that designed this. This was a collaboration. And the collaboration was around a set of open standards and meetings to help build these standards. And they were called RFCs. They were called Request for Comments. And there was a group that built these called the Internet Engineering Task Force, the IETF. And the request for comments is a fun notion. We're looking here at a September 1981 document, which is 40 years old about now. And it's called a request for comments. And the idea is, as engineers, we might have a design that everyone thinks is the greatest thing ever, but we should always question. No design is perfect. No design is beyond question. No design is beyond commentary. And so even when they're 40 years old and used worldwide and dang amazing, we still say there is room for improvement. And so this talks about, I think this one's IP, and there's an IPv6. There's another one. If you look for this RFC that we're looking at here, there'd be IPv6, and you'd start reading it. And it's pretty dense reading, but as an engineer, it gives you all the details to build a router or build a piece of software or build whatever. And these are 100% public documents. And the idea is that no company, because literally the companies that were around in 1960, if they had said Burroughs or Sperry owns the internet, or Digital Equipment owns the internet, they're all out of business, because they didn't make good choices, but the market was able to make good choices. And because the commons were these open standards and open specifications, new companies like Sun Microsystems and new operating systems like Linux could come in, and even Windows could come in and participate as full participants, because they just read these specs and all of a sudden they're interoperating with everybody else. This is fundamental and foundational to how the internet works. And I'm not saying you're supposed to go read them, but it's just fascinating to understand that the entire technological infrastructure upon which the internet is built is free, license-free, royalty-free, and you could build a brand new gadget and you could hook it to the internet by reading these specifications. You don't have to pay a developer's license or nothing. It's cool. Sorry, I'm just a little bit too excited about that. So let's take a look at one of these in particular. Now this is probably supplanted, but we'll look at RFC 2616. They go up in numbers, and so this is HTTP, Hypertext Transfer Protocol. And if you wanted to build a web browser or a web server, you could read this document. Go ahead, read the document. And if you read down far enough, you'll say, oh, this is how you make a request. blah, blah, blah. It's got a header and it's got like a carriage return line feed and then a message body, and you got to do this, and this is what it looks like. This is how it works, right? And so at some point, you're deep in this document and you're finding out in this page right here of this document how your browser is supposed to format it. And this tells both the client and the server what the rules of the protocol are. Now, it's a lot easier to just for me to tell you. So you connect to the server on a socket, usually port 80 or port 443, and then the client is supposed to make the first sound. It makes first request. It sends a line with a carriage return line feed at the end that has the characters. There's other ones, but get, GET, space, a URL, space, and then a protocol. And right now I'm using this HTTP 1.0 because I can do it by hand, right? And so you ask for a document, and then you can optionally send some header information, things like what language this person at this browser prefers, what are the capabilities of this browser, what version browser we have. So there's a series of things. You say, give me this document, and here's something about the browser that's requesting the document, including information like cookies that are being said. Now, so this, in case you want to know who is doing this request because you've logged somebody in and set a cookie to indicate that they're logged in, that's all sent on this GET request. But we'll not send the headers. There's actually incoming headers and then outgoing headers. We'll see these when we start looking at Firefox's debugging console. And so this is an entire interaction that you can do on your laptop. Now, I'm not going to do it for you, but I would note that the program Telnet that this uses has been removed from most computers. It makes me sad. They think of it as a security hole because it doesn't use encrypted connections. Like port 80 is not an encrypted connection. But ultimately, you can install, go search on your favorite search engine and find out how to install Telnet. But if you get in a command line, whether it's a Windows command line or a Mac command line or a Linux command line, and you get Telnet properly installed, you can type the following command: telnet datapr4e.org 80, and then hit enter. And at that point, so Telnet originally was used to log into computers, but if the server we're talking to and the protocol that we're talking to is simple enough, and in this case HTTP1 is simple enough for us to be able to do this, we're actually talking to the server, because remember I said that these are applications. Your browser is not talking to files. Your browser is talking to an application on a server, and the server might give you back a file. So it's really talking to a piece of software, and we'll see this in more detail in the next section. And so what will happen is, because the HTTP protocol requires that the client speak first, we have to type. Now, if you can get this working and type wrong things and type a couple enters, new lines, you will see that you're talking to a piece of software, and it will say, you have violated my protocol. You're not talking to a thing that has any online help or user interface or anything like that. You're talking to a server, and your job is to request some data using the proper format because you read the specifications about the proper format, right? So in this particular one, it's easier to cut and paste this, because some of these servers, if you don't type fast enough, they'll be like, you're not a software, you're a human, quit playing with me. Like you talk to Facebook or something, and you can talk to Facebook and see what happens on port 80. And it will time you out really fast. So it's good to have a cut and paste buffer. So you paste this get command in. And the other thing that's important is you got to put an extra blank line. And this extra blank line is to indicate that you're not going to send any of those headers. If we were going to send things like what language we would prefer or what formats we would prefer as a browser, the browser has certain languages and other configurations and login information, and that can get sent up to the web server along with the request for the document. And we would be able to type them in here. But we're not going to do that in this very simple. We're just going to say enter, which means no more headers. If you were putting in headers, you type header, 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 and then enter on a blank line, and then the server would know that our request was finished. But we can just ask for a page, and then what the server does is it sends us back two pieces of information. First, it sends us headers. The first header is HTTP 1.1 200 OK. That's actually a status line. Now, you'd have to go read the documentation on what that works. But for example, 200 means that you got a document. Another one that you might have seen is 404. It might say 404 not found. So if you go to a web page and it doesn't exist, something will say 404 in your browser, usually, unless it says, here's a search box, go find it. But there's a status, and so the thing that you're typing, page1.htm, may or may not be on this server. If it is, then you'll get a 200 OK and the data, or you'll get a 404 not found. And then we get some response data, some header response. And this header response looks pretty much like the same format of the data we would have sent into the browser if we were sending things like that in there. Here it's what the date is, what the server we're using, last modified, and one of the important things is what kind of content are you about to see. Content type in this case is text/HTML, which means the thing coming next. And then there's a blank line, and the blank line is our indication as we're reading this data that we've finished the header, which is really metadata about the page we're retrieving, and the actual page itself. And so the rest of this page is the actual data, and we know the format of it because we were told before the page starts. This could be image/PNG. This could be XML, application/XML. Then it could be JSON. It could be like anything. And then the browser is supposed to, and if this was an image, it would be like garble, 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 right? It would be all garbled stuff that we can't really see, but the browser knows what a PNG or JPEG looks like, and it shows it to you. And it basically uses this text/HTML to tell you what's going on. And so then your browser has read all this information. It has both the metadata and the data about the retrieved page, and then its job is to sort of produce a pretty rendered version of the page and show it to you. And that is the request response cycle. Again, you don't have to do this. You can just sort of believe that it's done here. But if you want to install Telnet on your system, it's not a bad thing to install Telnet. It's kind of a classic, fun thing. It's far less useful than it was in the early days because we used to use Telnet to test everything. Now we've got like browser developer consoles that are way easier than Telnet. But it's kind of a cool thing. Feel free to do this, and you'll be like, I know what's really going on. And so I'm a big fan of using the console, of using the terminal, of using text-based interfaces. I think they're actually way more accessible. I think it's awesome. And in a way, all these fancy graphical user interfaces distract us from the simplicity of what's going on inside of computers, because you think, well, where's the button? And the answer is, oh, there's probably some command inside this computer that does what the button does. So I have a former student of mine who actually wrote the scene in, I think, maybe it was Matrix 2. I think this was Matrix 2. Yeah, Matrix Reloaded. And this scene where Trinity is breaking into the power grid and she is using the console. And it turned out that the way this scene was written is it was written exactly as a hacker, whether that's a hacker with bad intent or good intent, because there are hackers with good intent who are trying to break into your system so they can tell you, you pay them to break into your system so that they can tell you your vulnerabilities. But you can take a look at the analysis of this little scene, and just this sort of is just one of the cool things about me teaching people about how to use the command line, and increasingly me teaching people about how to use Linux. I really think that it's okay to know your Mac and Windows command line, but really increasingly the world in the server world, and we're starting to work on web servers in this class, and you might as well start learning some Linux because that's an important skill. Just writing some Java code or Ruby code or Django code, that's a skill, but knowing how to start the server, debug your application, find log files, etc. in the command line is really important in real production systems, because we're going to play in some simplified environments to make it a little easier, but those simplified environments go away once you go into real production in a real job. And so I'm really into teaching you Linux, command line, etc., etc. So up next, we're going to show you in Python, in effect, as few lines as I can possibly show you, how a browser works, how a browser sends the HTTP protocol, how a server reacts to the HTTP protocol and returns documents. So that's what's coming up next. So network sockets are like phone calls for computers. And literally in the 1960s, when they were designing the concept for network software, that is the concept that they came up with. And that is that, in a sense, we make a call, we talk on the call, and we hang the phone up. And as computers were going to share data, and some computers were going to have data, and other computers were going to want data, they thought, oh, the way to do this is not necessarily have a permanent connection to that data, because there's going to be so many computers and so many sources of data and so many computers that want to consume those data. And of course, in 1960, they had no imagination that there would be billions. They just thought there would be 10,000, and they thought that was a lot. But they came up with a protocol that basically said, when you don't have continuous permanent access to data, you actually make a phone call, you know where the data is at, you kind of say, you dial up, you grab the stuff, you get it back, and then you let the connection go. And so it means that with billions of computers, each talking to each other, the network isn't so complex. And so there's this connect, talk, disconnect. Connect, talk, disconnect. And it's the way the phone system in our world scales to all the people, and it's the way the internet scales to all the people that want to use that internet. So this is made inside of software using an abstraction or library called sockets. And sockets really are computer phone calls. You know where you're going to call. You can start the call, wait for them to answer. Once they answer, there is a two-way communication. It's kind of like a file, except that you can simultaneously read from the file and write from the file. Although it's important for the two cooperating pieces of software to know who's going to read first and who's going to write first, because it's like if, when you pick the phone up after it rings, we all know to say, hello. And that's kind of a protocol. Who talks first is a protocol. And then the person goes like, who is this? And then eventually conversations happen pretty naturally. Somebody talks, listens, someone else talks, listens, and that works. But there's complicated protocols. And you can think of this not necessarily as the browser on your laptop or phone as talking to data on the server. It actually is talking to another program. And so even when it's just retrieving a file, it's talking to an application on that server, and that application is reading the file and sending it out. And we'll see that eventually, how we have to do that when we're doing things like uploading pictures. We upload pictures, and then we have to actually serve them back out. We can't just say, oh, the pictures are there, you can grab them. Because sometimes not everyone can see every picture. And so part of the software application decides, if you are allowed to see this picture, I will send it. If you're not allowed to see the picture, I will not send it. And so that's where it's a piece of software that you're talking, even if you're looking at a picture. Sometimes that software is really simple and you barely notice it, but there is software in the loop. It's not like you just go straight to data. It is really two pieces of computer software talking to each other, and we use the internet as that intermediary to allow that conversation to happen. So if you read my book about the TCP/IP, you'll learn this in super great detail. But every computer has an IP address. It is a number. There are two kinds of addresses. There's IPv4 and IPv6. IPv4 version 4 is the one that's got 4 dotted numbers, like 142.16.42.14. But within each of those, they have what's called a TCP port number. And because this whole internet thing is applications talking to applications, we need to have a good way to know which application we're talking to. And that's where TCP port numbers come in. And you can think of this as like a phone extension. So you have a phone number, and then you have, extension 1436. And so TCP port numbers are like that. So we can not have a specific address for every application, but an application that has an address and a port within that address, or a phone number and an extension within that phone number. And so you can look these things up. Port 25 is used for email, server-to-server communication. In the old days, we used this thing called Telnet. We'll talk about that on port 23. And so the client is on the right-hand side, and it might be a computer where you've got a keyboard and it's you, or it might be a server that's got some mail that's being forwarded from somewhere, and they all talk and they connect to an IP address. In this case, 74.208.28.177 is the IP address of this computer, and then port 25 is the extension where one computer sends email to another computer. And each of the arrows in between them is a separate protocol. So if you're talking to an email server, you expect to talk an email protocol. And if you're talking to a login server, you have a login protocol. That's kind of the simplest one. Or a web server. Web server can be on port 80 if it's unsecure. Preferred, of course, is HTTPS, which is on port 443. If you have a mail application like, say, Thunderbird that's reading Gmail, it talks to ports 109 or 110 or a couple of other ones that are ways for a mailbox application to talk a protocol to a server-based mailbox to retrieve the new messages or delete a message or view a message or whatever. So there are these ports on servers that have protocols, and then we can build software on our clients that talk these protocols. The one we're going to be playing with the most in development mode is port 80, and in production mode, port 443 for the HTTP for web documents basically, and web application documents. So up next we're going to take a quick look at the Hypertext Transfer Protocol. I always want to call it Hypertext Transport Protocol, HTTP, and that is the protocol that we talk to port 80 or port 443. So now we're going to build a very simple browser and server in Python. Okay, so we import a library, import socket, and that just like import math or import whatever, that pulls in a library into Python. Sockets are built into Python. It's very cool, and it's very, very simple. So sockets kind of function like files, but they're files that we can send data to and receive data to. But when you're using a file in Python, you've got to first open it. And so the opening of a file, of a socket, is really a two-step process. First, you create the socket, and that socket sort of lives in your computer as an endpoint that's not yet finished. It's the endpoint that you're going to send and receive data to inside your computer. But then we have to actually make the phone call. So socket.socket, and don't worry too much about this syntax, we don't change it. Socket.socket basically says make a phone. That's what we're making. And then mysock.connect, that second line, is dial the phone. And we're dialing the phone to a domain name, data.pr4e.org, and a port in that domain name. So that is the call. Now, if we made a mistake, right, if we were dialing and not talking to the right server, or that server didn't exist, this connect would blow up, meaning we'd make a phone call, a data phone call to a server that doesn't exist. That line is what's going to blow up. But as you continue down to the next line, if it gets that far, now you put try and excepts around this if there was but I want to keep this really short, so I'm not putting in all the stuff, all the error checking. So connect might blow up. Socket.socket won't blow up because it's like, unless you don't have networking at all in your computer, but it's unlikely these days. But mysock connect is like dial the phone, dial the data phone to this endpoint, and it includes the port 80 that we talked about before. And now we need to send a command. And in this command, it's exactly what we talked about before. It's exactly what we sent via telnet. It's a get, followed by a space, followed by our URL, followed by a space, followed by a protocol HTTP/1.0, and then we hit the enter. Now it turns out in network world you actually hit two things. It's the /r/n is a return and a new line. And you have to hit it twice, the enter at the beginning of the first line, and then remember we had to put that blank line in because to say no headers. Now we would put in between here, we'd put all our headers in there if we were going to do that, but we're not going to do that. And then you have to use encode, and encode means that the data sent across the internet is generally sent in what's called UTF-8. Inside of Python, the data is in Unicode, so that you can put literally any character in a Python string, and then preparing it to send it out across the internet, we kind of encode it into the more dense more compressed UTF-8 format rather than we don't send strings across the internet in Unicode in general. I mean, it's very rare, but you'd have to control both ends. We want to send them in UTF-8, and so the string get blah blah blah, that's a Unicode string in Python, and dot encode says convert this into a UTF-8 string, and so command CMD is a variable that has a UTF-8 string in it. And then we say send. Now remember I said that you can simultaneously send and receive on these sockets, but the protocol tells us whether the first thing we're supposed to do is listen or talk. And we're the browser in this case, and so we're supposed to talk first. So we send the request out, and that's just like you typed it in Telnet, because in effect you're scripting Telnet. Telnet, we liked Telnet in the old days because it was kind of like a socket. I could connect to any host, any port, and type things and see if it's broken or not. And then the protocol says once the server has received the first line, any headers, and then the blank line, then it's to return it. So then the next part of this is we're going to have a little loop. So the protocol tells us we are supposed to receive data until the socket's closed. And at the bottom of that telnet, you saw that it sent a bunch of lines, like 4, I think, and then it closed it. That's what's going on here. We are retrieving data, and then this receive, this actually waits. If the server is coming slow or the network is slow, this piece of Python will be sit. Oh, got a little bit, up to 512 characters. It will wait until it's gotten 512, or it's done and it's got 100 or so. But the receive is a blocking, waiting operation in Python. It says, give me up to the next 512 characters. Now, usually the network's so fast that the Python doesn't even wait because the operating system already has it. But we get it, and if we get no data whatsoever, that is our indication that the network connection, the socket has been hung up on, closed by the remote server, and away you go. So that's why we are going to break if the length of the data is less than 1. And if not, we're going to simply print out the data, but we're decoding it. And that's because the data that comes in is in UTF-8, but the print statement wants to print Unicode. And so decode says, here's a variable that has UTF-8 in it, convert it to Unicode for printing inside of Python. So because this data is externalized to us, we encode it before we send it, and we decode it when we receive it before we use it, because Python inside itself doesn't use UTF-8. Python inside itself uses Unicode, which is awesome and a whole separate conversation. I'm just kind of bringing that up to remind you how important it is, because we're not going to write much of this in Python, really, and all this stuff is taken care of for us in web servers when we get to that point. But it's just a good time to review Python's strings and Unicode and encode and decode, because it's really important. So if you run this and you've got it right, it runs pretty simply. Let's get the color back. Get back to yellow here. So if you run it in your system, Python socket1.py, all the work is done up here before you see your first output, and then all this output that you see is just this loop running. And what you see is really the exact headers that are coming from this server, and then you see a blank line, and then you see the actual page that's coming out. And you don't see it, but at the end here, the connection gets closed, and you break out, and you're done. And then we close our end of the socket. The far end was already closed. That's how we know to stop reading data. And then we hang ourselves up so that our local system does not end up with a bunch of half hung up phone calls. And so that's basically how we talk to a socket in Python. Now, that was literally 10 years ago how I would debug applications. I would like telnet or write a little thing like that and dump all the headers. And that got really tiring, really boring, really tiring. And so browser developer mode is going to be your friend. In a way, browser developer mode, and I'm going to have a separate video on this, browser developer mode lets you look at the sent headers, the received headers, the received data, the sent data, what URL it went to, and it's super awesome, especially because a lot of web pages have like 40 to 150 request response cycles. So you don't want to debug them all by hand. You just let the browser do its thing and say, what was that second one and what went wrong in the second one? I spend a lot of time when I'm debugging web applications using the developer mode, and that's why I have a special little video that gets you familiar with it. And I tell you, by the time you've done web stuff for a little while, you're going to know your browser developer mode. So next we're going to talk about writing code in the server to respond to these requests. So we build a browser in Python. It's time to build a web server in Python. So remember that what we've got here is we've got, the browser is an application, and we've made this a Python application now that sends this GET request. So we have effectively, like I said, built the world's simplest browser, and that sends a GET request. The server does something, and then it sends the response back. And now we're going to kind of change this, right? We're going to assume the browser exists, and it's like, okay, because we're going to be the server folks, right? So now we're going to look in greater detail at what goes on in the server. And so here is a very, very simple web server. It's a few more lines than the simplest web browser, because we have to put a little bit of error checking in with some tries and accepts. Okay, so let's walk through what this code does. Okay, let me change the color again to black. If you're from Microsoft and you can tell them to make a key to change the color on the scribbler, I'd greatly appreciate it. Oh, and then I went down a page too. Okay, so we're going to pull in some more stuff from the socket. We're going to pull in some stuff from the socket right here, and so we're going to make a function called create server that we're going to call right down here, and it's going to print out how you're supposed to access it and then start the server. Now the whole idea of the server is the server is woke up to wait for incoming connections. So the server already exists. So when you start talking to a web server, that server's in that computer already. The server software is already running, registering its interest in incoming request. So that's what we do. So when this Python program starts, it's going to sit there and wait in an infinite loop for incoming requests. So the first thing we do is we're going to make a socket. This looks very much like the time we made. It's an endpoint. It's not actually making the phone call. Remember I said this socket call is making the phone. So we're saying we're going to make a phone, and it's up to us later to decide if we're going to make a phone call or receive phone calls. And then this next thing is like the connect, except this is I am willing on port 90 to receive the phone calls. Now it turns out there's only one program on port 90 that can receive phone calls. So this might blow up. You might try to do this, port 9000. And if you run this twice, and you can do it in 2 windows on your computer, the second one will blow up and say, you can't have port 9000 because another piece of software has it. But as long as there's only one running, away you go. And that's part of this whole try except thing, because if you run this twice, it's going to blow up the second time, because you cannot receive phone calls on this server on port 9000 with 2 applications. One application gets the phone calls. That's what socket listen says. The 5 on there says, dear operating system, if I'm busy handling 1 phone call, you can hold on to 4 more and queue them, and then I'll come back and get them for you. And that you're asking the operating system to queue incoming calls. Don't just say you're busy, shut down. If you didn't say this, listen 5, if you were busy writing the data for phone call 1 and phone call 2 came in and you weren't ready for it right that instant, it would just deny the phone call. So that's what listen says is, dear operating system, hold those temporarily, I'll get back to you, which is how it works. And then what happens is we go into this accept. Now this accept is, I'm at the phone, I've registered what my number is and what my extension is, and I'm ready to pick the phone up. Let me know. So this accept is blocking. It stops, and it just sits there. And it can sit there forever. Just literally forever. If nobody calls it, nothing happens. The next line never runs until you blow it up or the server goes down. So that accept is a blocking. And the reason we do this accept, well, we have to establish the phone call first, right? So then this next line runs only when a phone call is received. So that means that we, on the browser side, we already connected, we made the phone call. Now we haven't sent any data yet, right? And so this is just now, at this point, somewhere out there, there's a piece of client software that has done a socket.connect, and we have done accept, and our accept has succeeded in the server, the connect has succeeded, and we are ready to talk. So the phone call has been made. Now the question is, who's going to say hello? And this is where the HTTP protocol solves our problem. The server knows that the client must speak first. So it just does a receive. Now you'll notice the receive and the send are the same function calls because it's a two-way thing. Whatever the browser is sending, the server is receiving, and whatever the server sends, the browser receives. And they can do it simultaneously if they can figure it out. But usually you kind of like say, it's your turn to listen and my turn to send, and then I'll listen. And usually they kind of go back and forth. In this, there's only one step. The server listens, gets the GET request, sends the data back. And so then we're going to read some data, and we're going to get 5,000 characters. We're going to get the whole thing. Remember, it's one line. It has a GET request in it. It has the optional parameters in it. And so we're going to split it. Now again, we've received it as UTF-8. We've got to decode it for UTF-16. I mean, not UTF-16, Unicode inside of Python. And then we split it based on new lines because the GET request is on one line, then header, 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 and then the blank line to tell us that we're into the headers. And we're only going to take, in this, we're just going to look at that first line. We're not going to do anything with it. Most servers actually look at the line to figure out what document to send. It's a very simple server. It sends the same document no matter what the URL is. All we do with the URL is we print it out to prove that we got it. And then we construct a response. And in this response, again, go back to RFC 2616 and it will tell you what this response is supposed to look like. It sends back a 200 OK. Remember, this is all the stuff we saw. Probably I cut and pasted it from a working thing. We tell it that we're sending it back in content type text HTML, the character set UTF-8. Remember I was telling you that. A blank line, and then some HTML. HTML body, hello world body. And I'm throwing in these /r/n's, which is the network's version of new lines. And then you will notice that I encode it before I send it because it's Unicode inside of Python, and it needs to be sent as UTF-8 because the phone, when you're in a socket, the thing that's going across the socket almost always is supposed to be UTF-8. So we encode it. And then because the protocol says so, as soon as we send the data, we close the connection. Now remember that the client had to close the connection too. So we close it, it's half closed, and then the client gets all of its data, gets the indication that it closed, knows it's finished all the data, and then the client shuts its side down. And so there are two hang-ups. It's kind of like a phone call. The person hangs up, and then click, you hang up. Now, you can't really keep talking, but you do want to have both sides hang up, and that shutdown is what's going on. And then the rest of this is all try except for various things. So we clean up our socket so we don't have to restart our server when our software blows up, and so the rest of it's pretty simple. And then, so this while one, the first browser will talk, and then it'll send some data, and then it'll go back and wait for the next phone call. And that's what's going on. The next phone call comes in, it sees a GET request, it sends the data back, then goes and waits for another phone call. So this is an infinite loop that sits and waits for incoming phone calls, and it answers the same thing. So it's like you call this phone number, and it goes, and you go, I would like a pizza. And it says, hello world, and then click, and then you call it up and say, I would like a car. And it says, hello world, click. And then you say, I would like to register for this class. And it says, hello world, click. So this is not a very flexible server. You will build far more flexible servers. But it's the one I could build and fit on a single page in a slide deck. So to run this, if you download this code, and it's a tiny bit of code, and you run it, so you go somewhere, maybe your laptop, maybe Python Anywhere. I don't know if it works on Python. It probably doesn't work on Python Anywhere because you can't actually talk to ports. But let's just run this on your laptop, and you start the server up. somewhere, get a hold of my sample code, or download it from here, server.py, and it's telling you this is just output from the server. And this is the moment at which it's waiting, right? It's waiting. The server could wait for hours at this point. But I just give you this in a print statement so you can copy that and put it into your browser. So you paste localhost 9000 into your browser, and then the server is printing that it got a GET request for the / document from this browser. That's what the browser send. I mean, we're talking from Firefox browser to the little web server that we just built. Now there's a second GET request that you don't even know because you didn't ask for it, and that's because the browser is built in to ask for a URL called favicon.ico so that it can make an icon, and that icon ends up in the tab or wherever in your browser. And so that's like an icon for the website. So you didn't ask the browser to do this, but it's a thing browsers do. And you'll see when you're looking at your debug logs when you're building stuff that it's a favicon. And so this happens like blink, blink, and now it's waiting again, right? And you could hit refresh, or you could go start a different browser, and you would see these GET requests. Every GET request you're going to see in your browser and your server. So it's working, and it works really well, and you're welcome to go ahead and play with it and try it all out. So now what we're going to do is build a simple web client, and then it'll talk to our server. So the other web client we made, talk to data.pr4e.org, this one is going to talk to yourself. So it almost looks identical, right? We're going to make a phone. We're making a phone. We're going to connect to localhost. 127.0.0.1 is the IPv4 connection, what's called loopback, right to the same host. We're talking to port 9000 because that's where we've got our web server running, that little web server we just wrote. And then we're going to send a GET request, a valid GET request to this thing, HTTP10, and then 2 new lines, and we're going to encode it into UTF-8 before we send it. Then we send it, and then we just have a loop that prints it all out, and then when the socket gets closed, we hit a break, and then we close our end of the socket. So the server clicks the phone, and then we're done with our data, but we've already printed it out, and then we hang up the phone on our end to kind of clean everything up all the way in between everything else. So this is a very simple web client. And so now you can run the web server, right, just like we did before. And instead of talking in a browser, we run this client. And this client gets a header of HTTP1 OK, its content type HTML, it gets a new line, and then the body, and we're done. Now, I mean, it's not a browser, but it is a client that's talking HTTP. And so now you'll notice that this server sort of sits and waits for incoming calls. You could run this over and over on the client, run the client over and over again, right? And then you would see more requests. But in general, the server is destined to just sit and wait for hours potentially until a client connects to it. And then at some point, you'll just abort this server. And then if you Control-C or blow this up somehow, this will fail. The client will fail, and it will fail. It will fail in this connect code. So if you want to play with it, try to run this client without running the server, and you'll see that the connect, which is the part of actually making the phone call, this will continue to work, which is make me a phone on my current computer, and then connect is make a call to the remote computer. That will blow up. And then if you wanted to play with this, you could put some try and accepts around it, say remote computer is not responding on port 9000. That's if you blew up. You could put a try and accept around that. But I'm not doing it because it don't fit on my slides. So here is an even simpler web client that we can use. And again, you can get this code from my sample code. We don't talk to this. There's a higher level thing that so the previous client talked to sockets, so I could show you the low level. But because we spend so much time talking about to URLs, we then have a URL lib. So I'm just going to use URL lib. And this could be a local host or it could be whatever. I'm just going to make a 4-line URL lib call. And so I just do a URL open of that same URL. Now we're operating at the HTTP level because the concept of URL is not a socket concept. The concept of URL is HTTP concept. And we just get, in effect, what looks like a file handle to us, and we loop through it and print it all out. So we run our server, and the server sort of says this and waits. And then when we run our client, it basically hits our server, and we can see in the server window. You got to do these two things in two windows, right? You got to do these things in two separate windows. So in the server window, it'll sit and wait, and then in the client window, when it runs, you'll see the client will make the request to the server, or blow up if the server is not running. And the server will see the GET request, and then the data will come back to the client. So you sort of do this in two things, and you can run the client over and over and over again, and you'll see every time you run the client, the server sees it, responds, and away you go. And again, our server always says hello world no matter what, which is delightful and classic. It's a classic. So you actually can watch when you're running Django. There will be a way for you to see when you're running Django locally and you start the server up. This managed we'll do this later, managed pi.run server, and then you talk to it, and you will see all the GET requests. And so Django, when you run it locally, you can debug a lot of what's going on. So you can see like the favicon that it's asking for, and that is 5 or 6 HTTP requests to produce that little Django web page. And so that will be something that you will learn how to do. And so that sums up what we're doing in this. At the beginning, you look at it very simply. Pretty soon, you'll just be looking at the developer console, and it'll all make sense to you. I want you to be able to know that you can dig as deep as you want to and understand all of these protocols that are going back and forth. Okay? Cheers. Hello, and welcome to another walkthrough for Django for Everybody. In this walkthrough, we're going to talk about the browser debugger console. And so this is something that in the old days was only in Firefox, but eventually everybody built it in, and you used to have to build a plugin. And it shows up at different places. And so in Firefox, it's here under Tools. It turns out that you can kind of go to any of these things because these are they're just different tabs here. In Chrome, we do View, Developer, JavaScript Console, and then you see a similar kind of thing here, right? So I'm going to do it in Firefox here. And so you can see things like you can see the document object model, you can see the JavaScript console. This little error hardly matters. It's because it's such a simple page. You can actually debug JavaScript code. You can watch the network. You can play with CSS, etc., etc., etc. Performance cookies are in here. So there's a lot of things that you can do. I'm going to start and show you right now. We're at the very beginning class. I'm just going to show you some of the most basic things here. I'm going to clear this out and then refresh the page. And so what you see here is you see each request response cycle, right? And so I came up here as if I type this. Let me clear it again so you see it. I'm going to type this. I'm going to press enter. And that tells the browser to go retrieve this page. So it connects to the server, www.drchuck.com, and gets the document page1.htm. This favicon.ico, that's basically getting this little favicon right here. That's the little thing that shows up in the tab bar. And so websites can have a file, and later we will actually make a favicon. But what I want to show you from a request response cycle is you can see some detail here. So let's go up here, and you can see detail. You can see that this was the URL. We sent a request, a GET request. We got back a status code. The status is the first thing. 200 is an OK. 404 is not found. And we used HTTP version 1.1. The request headers, they always show you the request headers, response headers first. So these request headers are actually part of the HTTP protocol where we are telling things like what my preferred language is, what kind of documents we can handle, and cookies that we're sending back in. We'll learn more about all of this stuff. And so this is actually when the browser makes the connection to port 80, sends the GET request to the URL it's interested in, GET http www.drchuck.com/page1.html space http 1.1. And then after it, it sends these. And this is pretty much the format, except colon, blah, blah, blah. And so that is and then it sends an empty line, and then it's done. And then the browser sends back first a set of headers. You know, what the content type is very important. The size is sometimes in here. gzip means that it compressed it on the way. And so these are the response headers. And so if I go to an error page, not a page.htm, so now I'm going to clear this. And what's happening here is it's putting up a page from my hosting system. But the most important one here is this, and that is the 404 error. And so it was going and it sent a GET request to http://drchuck.com, not a page.htm, and it got back a 404 not found. So that was that 404 not found is a different status code that said this is a thing that's not there. 500 means the server had an error, and we'll talk about all these codes. But the point is you can debug all this stuff quite nicely. So let me go back to page1.htm. So let's clear this and refresh it to make sure we got it all right. Okay, so we grabbed the page, and now I can, another thing that you probably by now have figured out to be able to do is inspect element. So now you're actually looking at this document object model, right? And so this document object model is not necessarily the code that came back from the server. If I go here to network and I click on get and I look at the response, this is the response down here. This is what actually came back from the server. And then the browser parses this and turns it into what's called the document object model. So this is the source. Now, just as for fun here, you'll notice that I can change the document object model here, right? If you are cool, you can switch to the second page. So you'll notice the document object model changed, and what I saw up here changed as well. And so this is like inspect element. I can do something like, I can even add here, I can add some CSS, style equals color :red semicolon. And if all goes well, there you go. You see I switched the color. This is the document object model. Now the server was completely uninvolved in that. And later we're going to write a lot of code to mess with the document object model. So the server is still, it doesn't have the red in here, it didn't change this to cool. So this is what we originally got from the server, and this is what we've got in the browser. And so once that page comes from the server, you or JavaScript can mess with that page. So it's pretty dang cool. Okay, so now I'm going to clear it, and I'm just going to click on the second page, which is an anchor. Let's inspect it. Well, it's an anchor tag, and so it's going to do another GET request. And so this time it went and grabbed page 2, and there's the second page, and you can go back to the first page. And so there's a lot of things that you can see. This persist logs is an important feature. That means that it keeps them across more than one request, and disable cache means that sometimes the browser wants to keep a copy of something, and you, while you're debugging, you want to say, hey, go get the original every time. And so this, right now I'm starting you on very simple pages, but if you take a more complex page, and I can never remember where it is, view, developer, network, let's go here. If you take a more complex page with a bunch of things in it, and you hit refresh on this page, you will see that it does a GET request, but then as it parses that GET request, it finds things like all kinds of stuff, right? So here this took 44 response cycles, 1.6 megabytes, and it took almost 1 second to download all that stuff, right? It took a second to download it. And so if you scroll all the way up to the top, the original GET request was to this URL, which is /lessons/rrc, which is the URL. But then if you were to look at the response, and I don't want to see that, I want to see the actual HTML. So if you look at the response, you see all these URLs for more stuff, some CSS or from JavaScript, some who knows what. And so then what you see is you see it then retrieving all these other things that it needs to actually construct the page, some CSS, grabbed a font, it grabbed jQuery, it grabbed time ago. That's a little thing like, and I grabbed a bunch of JavaScript and fonts and this, and then the translate. So you see this little translate thing? It's doing that. And so you'll see that's how it quickly builds up to about 44 request response cycles to produce a page. Now, so that's just my quick introduction to this. You may not see these little drop downs like this. You might have to turn them on in preferences. So you go into preferences somewhere. I turned them on a long time ago. I probably couldn't even find it, but you might see it. The other thing that I would suggest is don't use Safari, because Safari's trying to hide too much stuff. Like, it doesn't even show you the URL unless you click on it. So Safari's kind of a pain in the neck. And so I would suggest that for this class, you either use Firefox or you use Chrome in addition to using Safari. Safari is fine for daily use, but I just find it as a debugger, it's bad, which is really sad for Safari. They made Safari unfriendly to software developers, which means we're not going to test our stuff on Safari, which means if it breaks, too bad. Okay, well, enough of that little Safari diatribe. Again, I hope that you found this walkthrough for Django for Everybody, as usual, helpful. Cheers. Hello, and welcome to this lecture on the structure of a Django application. It's a little early to be going through all the detail, and there'll be some things that we're not really going to understand until a little bit later in the course. But I wanted to sort of show you the lay of the land so that as we add features, you realize that there's sort of a method to the madness. And so Django is a way of building web applications. Django has a pattern within itself that, you know, it organizes folders in a certain way and puts files in certain places. And we're going to build these projects and applications, and you're like, why are these things organized the way they are? Well, it has to do with the fact that if you go from one Django project to another Django project, you can, you know, fit right in and understand how things are going to work. So the important terminology that's, I don't know, a bit frustrating is there is projects and applications. And from Django has this notion of you have applications, and you might have a project, which is really basically a website, and then, you know, some applications. But if you had two projects, you could share applications between them. And so it's one or more applications per project, with the ability to potentially reuse a application across multiple projects. And so we're going to work with my DJ4E samples, which I hope you have downloaded somewhere, at least so that you can look at the files, look at the folders, look at the names of the files, and look at the contents of the files. This will all make more sense when you get a little farther down the road. So here is an ls statement, ls-l, DJ4E samples, and hello. This is within the folder DJ4E samples. There are two basic folders. One is, in effect, the project-wide settings, which is the same name as the folder that we're in. So it's DJ4E samples / DJ4E samples. And then there's the first application, which is hello. And there's a couple things here, like the __ init.py. You'll notice it's an empty file. It's just some bookkeeping that helps Python know that there are files that contain classes and objects in here. Settings.py and urls.py and wgsi.py is kind of like the traffic cop for this entire application that routes things coming into the right, this entire project that routes things to the right application. And then within the application we have some files. And you really are going to learn a lot about object-oriented programming because all these files contain objects. So Django is a large piece of software, and you change its behavior by defining objects that accomplish things and then in effect registering those objects. So a common thing will be to take something like, you know, admin.py or models.py, create a data model, and then tell the admin user interface that you didn't write how to show your model, and so you write stuff in admin.py to communicate into the admin user interface how your data model that Django currently knows nothing about is supposed to be shown, etc., etc. And so there's a lot of files, and we will talk through these files. Now, This is an example of a request response. It's a web application, and so what we'll talk about is once a request makes it into the server, it's going to do some work and then produce a response. But in that, we're going to look at all of the work that goes back and forth. And there's effectively like a routing step where it picks what part of your application to route this request to. There is a view part, which is going to receive it and potentially store data. Some would call that the model. The storing of the data is certainly the model, but the receiving of the possibly new input data, like you're going to create a new thing, that would be the model. And then the view, at some point you got to finish it and send something back out, and that's the purpose of the view. We call this pattern for building web applications, model view controller. And it's not like you can't build applications any other way. It's just by saying, it's a terminology that I can say going forward, that's the model, that's the view, and that's a controller function. And you don't have to know it right now, but these are words that they're loaded and have valuable meaning to us to be able to do. So at some point in this picture on the left side, we have a browser. DOM stands for the Document Object Model. And at some point, the person clicks somewhere in the current web page they're looking at, and the web browser intercepts that and says, oh, okay, I've got your click right here. The web browser intercepts it and then makes a socket connection across the internet, which we've seen before, and then does a GET request. And that is what then goes into the server. And so the three functions are the routing, the views, and the models. And there is an overall configuration file, the settings.py, which is sort of how you just say, oh, here's my view files, read these view files, read these model files. So the settings.py kind of controls everything. But when a request first comes in, it consults urls.py, and then for the project, and then it will include urls.pys from each of the applications. So once it's chosen what view to run, it looks at the URL, pulls out the pieces of the URL, and finds the views in views.py. That's a Python file that has the destinations for these incoming URLs. There's a file called forms.py, which we'll see later, that is used to make the forms aspect, the part that you fill in, as pretty as possible. And then we take the resulting data that we're going to send back and we merge that in through what's called a template. And then if there's any data that we need stored, we call the model and we store that in a database. And there's this file called model.py, which informs how we store data in the database. And then when that's all done, we read potentially new data from the database, merge that into a template, and then send a response back to the browser, and then that response is all shown to the end user. And so that really is the request into the server through a Django application, pulling data from various places, merging a template back in, and then sending a response back to the application. So up next, we're going to talk about virtual hosting. Now, in general, you're not going to have to worry about this. It just kind of explains how something like Python Anywhere is able to manage a whole lot of domains on a single system.
Hello and welcome to a demonstration for Django for everybody. This is to install Django on Python Anywhere. In a sense, we're going to just be getting started. This is a bit tricky because there's a tutorial on how to write your first Django application. There's a tutorial on how to set up Django.org on Python Anywhere. And neither of these are exactly perfect. So what I've got is an assignment that sort of walks you through a series of things that lay down some necessary things for this class. And so the first thing we're going to do is you should have a Python Anywhere account. And you should be able to log in on the Python Anywhere account, and you should be able to get somewhere. So this is my Dr. Chuck. This is my account that I use to I used to be a student on this. There's other accounts that I have for the production stuff, but this is one of my student accounts. And so the first thing you're going to do is you're going to use a console, and you're going to start a bash shell. So this is actually Linux, and I love Python Anywhere. I love the fact that we're learning Linux. Hopefully you'll just get a little more comfort with Linux as we go. But this is where you're going to do a lot of the command line of the system. So we're going to do make dir virtual environment. You might be able to make this Python 3.7 or Python 3.8. The later that Python is, the better. This is going to take a while because it's going to create what's called a virtual environment that allows you to have your own version of Python, your own set of installed Python libraries, and virtual environments are a wonderful thing in Python because then you don't have to ask the owner of this system, which is Python Anywhere, hey, could you upgrade the Python? Turns out you can upgrade the Python all by yourself. So we will sit and let this, oh, there we go. It ran right away. And ran right away. So let's go do the next thing. The next thing I know takes a long time. So the next step is to install Django. Now this is pip is installing software. So it's going to download a bunch of software and then it's going to install that software and it's installing it in our Django 3 environment, right? And so this is not installing it for the whole system. It's just installing it for us. And so you'll get used to the idea that you've got to work on the Django in your appropriate Django environment. And we're using Django 3.0 in this situation. As the recording of this, Django 3.0.2 is out. Django 3 is quite nice. So we'll just sit and watch this for a while. So it's finished, and now we have it installed. Now there's a command that gets us into, this is redundant right now because we're already in it, but work on Django 3 and make sure that you're in it. Then the next thing to do is grab this command and make sure your Django version is right. If that says 3.02 or later, then life is good and you have your Django working. Now, I want to also have you install some of the sample code in the class. Let me get this started and I'll explain what's going on. So this is GitHub, and this is code that I maintain, and I can update this code and I can send it to you. And so this is a lot of sample code. So if you go to DJ4E tab, I hit the tab key to do completion there. There is a bunch of files in here, and this is the kind of sample code that we're going to go through in the class. And so we need to add the requirements. Pip, again, is the dependency manager. There's a file requirements.txt that says, hey, we need a whole bunch of libraries. And so let's install those libraries. Now, in your first Python applications, you're not going to need all of these libraries, but I want to get them installed into your virtual environment early on so that as we go along, you're not going to add a feature like social authentication, which is this little application right there, like social authentication, and then oops, we had to install a thing. So I want to get all that stuff installed at the beginning. And this will take a little while, so we'll just pause for a bit. Okay, so that finished. And now what we want to do is run a command, manage.py check. You're going to run this command a lot. And this, we're in actually a Django application, and this Python manage py check reads through your files and these files that point to other files, looks for syntax errors, and it's a good way to check the sanity of your application, because if it won't pass this manage.py check, it's not going to start. We haven't even tried to start this application yet and put it up on the web. For now, we're doing that. So don't worry about this message. We'll get to that later. We can say Python 3 manage make migrations, and in this one it's going to say no change detected, and then we're going to run migrate, and that will create a bunch of database tables. Don't worry too much about that. So we've finished there. Now we're going to actually pick up in the Django application, but we're going to basically make a new Django. We're going to make a folder. So we're going to go back to our home directory. CD tilde says go back to home directory. And we're going to make a directory called Django projects. This is so you can have more than one of them. We're going to go into that directory, cd Django projects, and then we're going to start the project my test site. Now what this does is this actually created a whole bunch of files in my test site. Okay. Now we do have to edit one file. I'm going to edit this file. Now I have a whole thing on how to edit files on Python Anywhere. I'll do it I'll do it the way you probably will do it, and that is use this files screen. Oops, I have to go back and get my shell, dang it. Console, open like a new tab. You'll find that you'll want to go back to that console. So here I am. I want to edit some files, so I can go into Django projects, my site, and then settings.py is the file that it's telling me to edit. So it's just my site. It's a little weird that the name is doubled. You got to go down to around line 28 and say add quote star quote. And that has to do with protecting what systems can talk to this web server, and we're just going to say anybody can do it. Do not set this default. Forget this warning. It's a lie. We are not in production. We are in development. So then we have to say save. So then we'll save our file. Okay. So let's go back. We had to do that. Here's different ways of editing the file. You could use nano on the command line. That's cool. I just use this #1 way to do that. VI is really cool, but we won't do that. Okay, so now we need to convince Python Anywhere to run the application. Okay, and so that is under another tab. That is under, and I'm going to open this in a new tab. So now I have these files. Actually, I don't need this tab anymore. I have my, oh, I should oops. I should say Python 3 manage.py check here just to kind of be creative. Yeah, that's good. So you always want to do Python 3. I'm in this file, the site, the actual website that has manage.py in it. Python, actually, you don't have to say Python 3 anymore. It's after the year 2020. So you can say Python manage.py.check. You'll see me type Python 3 all the time because old habits die hard during the transition from Python 2 to type Python 3. So that's good. That suggests that this application in Django projects is in good shape. So now I have to go look at this web app setup. And what's going on here is this is Python Anywhere's way of taking the code in that folder and running it and giving you a web address for that. And so the first thing you got to do is you got to set this up. This is correctly set up. You got to point to the folder that has that manage.py in it. And if I go to the console and type pwd, print working directory, you see home Django Dr. Chuck's my site. And this is the file that has the folder that has manage.py in it. So these two things have got to be right. This code here has also got to be right. When you see this, it's going to start out really big. Throw it all away, throw the sample away. I give you the entire code to put in there. And again, it's all setting up which site. And then, we also have to set the virtual environment in this web tab. Go back to the web tab. We've got to set this virtual environment. And I want that to be, you gotta go and change the name of it. Don't do the same as me. This is for my virtual environment. So it checks, yep, there's a good virtual environment. So you gotta have this source code, working directory, WSGI configuration file, and virtual environment set properly. We'll come back to this. These are error logs. And if all goes well at this point, let's double check the assignment. Hit the reload. It's what it says. So every time you change your code, you have to tell Python Anywhere. So this takes a little bit. And if all goes well, I will open this URL in a new tab. And it worked! Debug is true. Please leave debug true, or else this course is going to be really tiresome for you. Okay, so that's the first step, but then we have a little bit more work to do. We're going to add a polls application. So we're going to go back into that. I'm already in that folder. I'm in that folder, and then I'm going to start an application. Oops, come back. I'm going to build an application. This is a way to create a bunch of source code. So one of the things about Django is that it comes with batteries included, and so in this particular case, it's writing a bunch of code in a folder named polls. Okay, and so that's now in polls, and then we go continue on our, now we're going to pick up in this Django tutorial. So we said start at polls, we did that, and we're going to edit a file, polls/views.py, and we're going to, I'll copy this code here. Open a new tab, and Django projects, my site, polls, views.py. So I'm going to put that code from the tutorial in there. Okay, so that code is in the tutorial. Going back to the tutorial, it says create a file called urls.py in that same folder. And put in this code. So I'll copy this. So I'm going to create a new file here, urls.py, new file. Let's put that stuff in there and save that file. Then we go back. And then we are going to go in the my site. So polls urls.py is an application. My site is for the entire site. And so I'll grab this code also. This file already exists. So we go my site, settings. This is the only folder that has settings.py in it. Oh, I wasn't supposed to edit settings. I was supposed to edit URLs. And this looks pretty good. We'll just add the line. Well, actually, we got to do all of it because we have to import the include. So this little import include, this little part here was there. So this was, I copied this. These are all, of course, comments. So all these files are just some Python. This is setting a variable called URL patterns to an array, and path is a thing that returns an object. And so you can go read and you should read all the documentation. And then I will save this. And then let's go back. Now, every time you see here when it says Python 3 manage run server, you want to go do Python 3 manage check. So that's like do everything but run server except run the server. And again, you could get errors here and read those errors. They're tracebacks. You'll say, oh, no comma found. Let me just make a mistake so you see what happens. I'm not making mistakes. Come back. Let's go into this file. Let's forget a parenthesis. Okay? Let's save it. Shocking. See? So now, when I did a Python 3 manage py check, it blows up and it tells me, oh, something's kind of funky around line 22 of urls.py. Looky look. I mean, my editor even told me that. So there we go. So I fix that back up and I say save. And now I go back and I type, by the way, you can hit up arrow and you can run a command again. Python 3 manage.py finds no issues. So then what do we do to test our application? We go to the web app. Now we've got these guys set up. We don't have to change those. They're all set up again. So we hit the reload button. Take a little bit of moment. Then we go over to our actual application. Now this looks like a failure, but it's not, because it turns out that that little bit of code you run is sitting in polls. And so that's the code that you ran. And so at this point, you have completed the assignment. I got a little bit about errors down there, but so we walked through that. Wasn't too bad. Getting things set up is often the hardest bit, but hopefully in a little bit of time you'll have it all working, and then we'll start adding things to our application. So hope this was helpful. Cheers.
Hello and welcome to our lecture on HTML, the hypertext markup language. So we're going to place this in the context of our request response cycle, and sort of here's us in the request response cycle in our browser and what we're seeing. We make a click, it goes across the network to the web server, runs some code, maybe talks to a database, formats up some new stuff, and we get the response. Then HTML comes out, and then that's parsed to make the DOM, and what we see is the document object model. And we're going to ignore most of that in this lecture. We are really only going to talk about this part here, and that is what this response is. It's HTML, and it is parsed, and it's read through, and it's used to construct the document object model, which then shows what we see. And so HTML is just a technique of using some special characters, less than and greater than, to add tags to indicate what we want to see, like the paragraph tag. The paragraph tag, that's a paragraph tag. Strong tag makes things bold, emphasize tag, and a paragraph tag. And so we have these tags and we just mark up. We're communicating meaning. If you're old enough to remember, word processors used to have ways to look at the actual codes that were being stored in the word processor file. So the web is, the HTML and hypertext transport protocol and all that stuff is a relatively recent invention, and we're doing so many cool things with it. It's continuously evolving, and really, we're less than, we're 20 years old, and so we're doing so much with it. It's continuously evolving. So HTML and CSS are really kind of at the edge. Looking back in the early days, if we take a look at what HTML was really intended to do, it worked on a Next computer in the early 1990s, and so this is the Next browser, which came from CERN, and it had everything in a new window. Images were not shown in line. And then there was the NCSA Mosaic browser, which was the first browser that was universally available on Unix, Windows, and Macintosh. And you see things like gray background and blue links and highlighted links that you visited in purple. And so in the early days, it was nothing like what we see today. In the early days, we were just amazed and happy that we could see a link, and you'd click a link and something would happen. But today, money is to be made based on making stuff super beautiful, and the number of pixels, and how things line up, and how things are shoved over, and how navigation looks. And so today we need to create beautiful web pages, whereas in the old days, we were just amazed to have web pages that worked in the first place. And of course, computers have gotten much faster, capable of handling video and images. Back in the old days, images were costly, both for network bandwidth and for the time it took your computer to display them. And so that just affected how we did it. And it's kind of fun to use the Wayback Machine, otherwise known as the Internet Archive, to go back and look at some of these older web pages and realize that it's still amazing that a lot of them pretty much work. And in the good old days, HTML was kind of a Wild West. The browsers did not want to show broken HTML as broken HTML, and so they compensated for it. And so in the old days, we had things like tags that could be uppercase. We would have a paragraph tag that didn't finish. We would have li tags that didn't finish. We would have attributes that didn't even have double quotes in them. So there was all kinds of stuff, and literally you can take this bad page and you could put it into a web browser and it will still display. So HTML, while it technically is a very precise language and you can make syntax errors, browsers are extremely flexible in terms of parsing it. Now, you're not going to get predictable results. Like browsers can go into what's called quirks mode. And so in order to create the standards environment that we have today, Tim Berners-Lee, one of the original founders of the World Wide Web, helped found an organization called the World Wide Web Consortium, or the W3C. And it really decided that instead of just letting people write a browser and having HTML be defined by the browser, instead they would write a spec for what HTML was, and then multiple vendors could produce the browsers. And it took a while for this to become successful, but there was a need for every vendor to build a web browser, and so they worked with the World Wide Web Consortium. And like the mid and late 90s, 95, 96, well 94 through 98, 99, the World Web Consortium created a lot of wonderful standards around the World Wide Web. Now, once we started having rules, then we tend to want to follow those rules. And so tags need to be lowercase. Attributes like this image source equals, have to have double quotes around them. You have to have open tags and closed tags, open tags and closed tags. And so there's a set of rules, and now we are much more precise about our HTML, and we try to write it as precise as we can so that we get the best performance and the best sort of rendering out of the browsers that we can possibly get. Because if you don't write precise HTML, then the browsers are going to make decisions as to how to render things, whereas if you write precise HTML, then you really are in control of how the browser lays things out. So up next, we're going to talk about HTML itself, look at some HTML documents, and take a look at the syntax of HTML. Welcome back. So let's talk about some of the basic syntax of HTML. The first thing is to look at the overall document layout. And they start with an HTML tag. You might have a thing called a doc type up here, and we can put in one if we like, but HTML is the outer tag, and then there is a head tag and an end head tag, and this is sort of non-printing information. We set styling up, we declare the title of a page, perhaps load some JavaScript, and then the printable page of the content is in between a body tag, and mostly what we're going to talk about is the stuff that we put in as page content. So you'll find that there are special file names that we use. It really has to do with the fact that what we do is we make a directory within the web server, and when we go visit the directory, the web server looks through a series of files that it's configured to look to, things like index.html, index.htm, or index.php, and each one has a slightly different order and a slightly different set of things. It might even be called default.htm or default.asp if you're on a Windows box. It is configurable, so different systems do things differently, but usually index.htm is probably the safest thing unless you're doing PHP, which we will be doing later in index.php. And so those are usually the safe bet. Now, when you're viewing things off of disk, which we can do, if you download all the code that I've got in html.zip, then you'll have to open the index.html by hand. So we can put multiple files in the same directory, and then we can use them in what are called relative links. And so we can easily create links between one file and another. And so you'll tend to see, if you look at the zip file, that you've got a whole bunch of files in the same directory. And with little anchor tags, they point back and forth between each one. And so, like I said, you got tags like the paragraph tag, the strong tag, and the emphasize tag. They have to start, they have to stop. But another thing that's really important about HTML is the fact that most of the time we are logically marking up the text. And so we're saying we want this stuff right here to be a paragraph. But the end of the lines that we put in the HTML that we write are not really that important. What happens is depending on the width of the browser, if you change the width of the browser, the text will be rewrapped. And that's because there's still a paragraph, but we don't want to hard code it because we're not working on paper. Sometimes browsers are really large, sometimes browsers are really small. Sometimes you're on a phone, right? And on a phone, browser's really small. And so you don't want to tell exactly how many pixels it is wide, except when you start doing really fancy layout. But in things like paragraphs, you just say, hey, make it a paragraph and rewrap it. And that also, the rewrapping then also changes how tall the pages are, because the narrower pages, it kind of extends the page down. But the white space inside of the HTML is really generally ignored, and the lines are generally ignored. There are some tags, like the pre-tag, that changes that, so white space is respected and new lines are respected. But most of the time we just let the browser rewrap things, and it's good. You have beginning tags and ending tags. So here's a beginning tag and then here's the ending tag. The slash is our indication of an ending, and they're paired. And they're also nested. So this P tag has a strong tag within it and an M tag within it, and that's totally okay because this whole thing is a paragraph and this is a piece of bold text. So they have beginning and end, and slash is the end. You can also have self-closing tags that have like an image tag that has like a slash, and that means that you don't have to have like a slash image over here. That's the same. You just put a slash here and it self-closes. Another thing that you will get used to is the fact that you can put on the opening tag attributes, so key value pairs. And you'll go define what you go read the documentation on the image tag and it'll say, oh, put a source attribute on to say what picture, what file we want to display as the picture. The image tag is to show pictures, basically. So given that less than and greater than and other things are special characters, we have to have a way to print the special characters. So how do we print a special character? Well, we use ampersand LT semicolon, and there's a whole list of these things. HTML special characters. And you can look them up. And there's some that are kind of fun, like the special characters for the deck of cards. There's mathematical special characters, and you go look these up and you can find them. The key thing is they're cute, and you'll see that I'll use some of these arrows in the things that I'm doing. But the key ones that you really need to know about are less than, greater than, and ampersand. And just because ampersand becomes a special character, less than, greater than, or ampersand are really the special characters in HTML. And so to represent less than, you do ampersand LT, ampersand GT, and ampersand MP semicolon to get those things right. HTML comments, like in any programming language, any situation, the start of an HTML comment is less than exclamation dash dash. It's a little clunky, but we just want to make sure it's really clear. And so dash dash less than comments can go across many lines if that's what you want to do. So that works as well. Links is a critical element of HTML. It's why search engines work. It's why, when I first saw it, I'm like, I click on a thing and there's a new page. Isn't that amazing, right? And so hyperlinks is the H in HTML. It's the H in HTTP. And so it is how we, in effect, use this thing that we're sort of just scribbling on to create knowledge that Google then can extract. And so the anchor tag, the A tag, is the tag that we use to do these things. And so, there's a header one, a paragraph, and the anchor tag this is the start tag and this is the end tag. And so the text that's clickable is second page, and you can see that it's clickable right there. It is styled with a underline and blue to indicate that it's a link. And so there's the href, which stands for hypertext reference, and then it's an attribute, so it's key value with double quotes, and then this is another URL. And so that's like, in effect, putting that URL up and going into that next page. So it's a hotspot. In the early days, and I'll show you a few of these links were like the coolest thing ever, and so we made them pretty colors, like the blue with the dash. People didn't when they first saw the web, they didn't know to click places, so we sort of styled them quite brightly. And then because you were often scanning and searching the whole web, because the web wasn't so big in the beginning, we would mark them as purple after you'd been to it. So you could sort of slowly but surely work your way through the whole internet as it existed back in the old days and keep track of the ones so you didn't have to go back to the ones that you'd seen before. And that was an absolute link, and here's one with a relative link, and that assumes that we are now in the same folder, same directory on the server, where we have href, and so here's the start tag, here's the end tag, and then first page is the clickable stuff. And you'll note that that is a purple link because I have already been there, because page1.htm was exactly where I just came from. And so you click on that, and then you can go back and forth, and those are the pages we played with in the HTTP lecture. And so these absolute references are references that start with, HTTP or HTTPS or whatever, and relative references don't. And so that basically means that this page1.htm file has to be in the same folder as whatever file we happen to be viewing right now on the same server. So if you want to switch folders or switch servers, you have to use absolute references. And if you are just moving between files on the same server, you can use relative references. Images are a lot of fun. In CSS, we'll see how to wrap text. One of my favorite things was to wrap text. There is an image tag, which we saw before, image, and then the source equals is the attribute, and then in quotes the name of the file. And it can either be an image that's all by itself. In this case, this paragraph is what we're seeing, and you can see that this image is a tiny image, but it's sort of like blah 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 blah. The image right here works kind of like a character. You got to be careful because the images can be really big. That's why I made a tiny image. And you could even, for example, in this case, I have an anchor tag, and the clickable part of the anchor tag is an image. So if you click right there, that will move you to lists.html. And so you can make an image be a hypertext reference as well. Now we're going to do much more with these things, and this is just, at this point, the basics. Lists are an important part of HTML. There's ordered lists and unordered lists. And so the unordered list starts with the UL tag and ends with a UL tag, and then that sort of bounds the whole list. And then each list element starts with an LI, list item, and /LI. And I want a little bit of spacing. If you don't put them in paragraphs, you don't quite get the default spacing. This blank line is really coming from the paragraphs. So I'm putting a list of paragraphs, basically. It doesn't have to be a list of paragraphs. You could make a little denser list with a list of links or something, but I'm putting paragraphs in. And so you can see that I have LI to end LI, LI to end LI. I'm putting some links in here, etc., etc. And so dot, 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 and it puts all the bullets in. It does the indenting automatically. We'll see in a bit how we can control all that formatting and do different things if we want to do those different things. But for now, we're just going to play with the default formatting and learn the HTML, which is our way of representing that we want a list on the screen, but we're not so fancy about exactly how it's supposed to look. So in HTML, we really are looking for the meaning of the page, not how pretty it is. Tables. Tables have a bit of a checkered past. In the early days, people tended to use tables to lay pages out on grids. And they would just put, a paragraph here and a paragraph here and then a paragraph underneath it, and they would move them around, and they would put images in some of the table cells. And that turned out to be really bad, and that notion of tables as graphic layout is long gone, and we use CSS now, which is the next lecture. But tables were always a good idea for tabular data. And so if you have something that sort of makes sense, is like a list of cars with some make, model, and mileage columns and a list, then you mark them up. And so the table markup is pretty straightforward. We start a table with the table tag, and then we have a series of rows using the tr tag, tr to /tr. And then if there's a header line, which can be formatted a little bit different, we do a th to /th. And then this basically says it's going to be a 3-column table because we have 3 table headers, 1, 2, 3. And then we're going to put TDs for the data. TD stands for data, 1, 2, 3. And so that's the Ford, edge, and then the mileage of that, and on and on and on and on as we go. And so it's not hard to build them. You kind of have to keep track of how many of these things you've got. And there are tricks where you can make a table that has like 4 things, but then in one row this expands so that I can't erase it. Can't erase it. So there are ways to do things where a data element spans more than one column, call span, for example. But the key to tables is that we use them for tables. We don't use them for arranging things that are not themselves row, 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 row. So I'm going to stop there. I'm going to record some exploration of some sample code at www.webapplicationsforeverybody.com/code/html. And I really am intending that you will, these are very simple pages, but the idea is to look at them in developer mode and take a look at them, and then you can see how the various things work. And you can also then look at the source code and see, oh, here's how a pre-tag works. Or where's the pre-tag? No. Oh. Yeah. So we look at the source code, take a look at things, and show that the line wrapping does not actually matter. We look at pre-tag in another one. So I'll record some walkthroughs of all this sample code, but I encourage you to take a look at it because it has a lot of good examples of the basics of HTML. And so HTML is a continually evolving thing. It's a very creative space. It's a lot of fun. We have to be really tempted. We have to avoid the temptation of trying to make everything look pretty in the HTML, but instead delegate that to the CSS, which is what we're going to talk about next.
Hello and welcome to Web Applications for Everybody. In this screencast, we are going to play with some of the sample code, and you can either download it and play with it on your own computer, or you can look at it in your text editor, or if you just want to browse it, you can browse it here and take a look at the version that I'm using. It's really been intended that you look at this in the developer tools, and so you can do things like, say, inspect element. And so here we are. This will also be a little more valuable even when we're doing CSS, but you can see the document object model. Now the interesting thing here is it shows something I'm always talking about, is the difference between the document object model and the source code. So this is the document object model. It's kind of stylized. If you look at the source code, you have to say view page source. And so the source code, this is literally exactly what's in the file. And if you go look at this file in a text editor, you will see this. And if you're looking at it here, it doesn't quite look exactly the same, and some things have been done a little bit differently. You know, they kind of got this extra stuff, and this is kind of after the browser has looked at it. And when we start talking about JavaScript and changing some of this dynamically, you'll see this part is the document object model, but the source never changes. The source is what was originally downloaded when the server sent this back to us. So let's take a basic look at this. I'll hide this unless I need it. I'll go back and forth between the source. So we have a basic document, HTML, with a head tag and a body, and then a header. And of course, here's our header. We're using default styling, and paragraphs are an important part of things. You can squeeze this up as much as you want. White space sort of doesn't matter, right? So this white space kind of doesn't matter here. The fact that this has got extra space, it doesn't much matter. And so you can see an anchor to a strong tag that leads to a boldness. Let's just go ahead and look at it here in the inspect. We'll go down here, we'll find like a strong tag, that's the bold. We got an emphasize tag, and if you look a little farther, you'll see there is the anchor tag, which is the whole anchor tag is this whole tag from the A to the /A list.htm. That's where we're going to go if we click on this text right here. And so you can see, now this is a relative link, and it turns it into an absolute link, and that's because the browser knows where we're at. And so it sort of prefixes everything up to that to the relative link. But that's nice, because if we look in folders, we will see that these folders are all here. Here, let me go find you that folder. It's pretty deep in my... Later, this will all make wonderful sense to you. I do a lot of stuff with web. Code, HTML. Okay, so here we have, after all that, here we have the files, right? And so this is index.htm, and index.htm is right there, and list.htm. And so if I click here, I'll go to list.htm, and that'll pull this other file up. And so these guys are all in the same folder together. It just means that I can use relative links to go moving between them. A tag that's really becomes more important, especially as when we're talking about writing code inside HTML and showing people code, is the pre-tag. And so the pre-tag, and you can just say inspect to hop right down to where the pre-tag is. The pre-tag respects spaces, so all these spaces happen, the new lines happen, and it also shows it in monospace font. Now you can change all these things once we get to CSS, but pre-tag, when we're printing debug out from, not in files like this, but when running code, sometimes it's good to print debugging out
in pre-tags. So let's go to the next page. And so here's a whole series of things we're going to play with. This is a unnumbered list. This whole thing is an unnumbered list from top to bottom. So when I highlight this, you see the whole beginning to end of the list. Then each item in the list has a start and end LI tag, right? Down, down, down. You know, so here's this. We should learn about tables, and there's a href. There's another relative link, and so this is sort of my jumping off page to get to all those other things, right? Learn about tables, etc., etc. And so you can see these. We probably use just to take a look at the source code of this page. And so that's the source code that I typed in, and you can see the LI tags, the P tags. I'm putting P's inside of LIs to get space. Let's see if I can sort of show you that. So if you look at this, and you look at the LI tag is that, and the paragraph is what actually creates the vertical and horizontal space, right? So that orange that you're seeing, that's paragraph. There's space that the paragraph tag has preset. So that's how I do that, putting paragraphs and hrefs, and so that's what this all looks like. So let's take a look at special characters. And so this is an interesting thing because it's not really what came out, because less than requires ampersand LT, but it's kind of processing that. So let's take a look at the source code to this one, because that'll be more instructive. So ampersand LT, ampersand GT, ampersand amp. This is an ampersand in HTML, and then just the letters AMP semicolon. Semicolon's not special. There are only really three truly special characters: less than, greater than, and ampersand. And you can put all kinds of fun stuff: clubs, hearts, and diamonds. And so you got the clubs, hearts, and diamonds, some arrows, stuff like that. What's nice is browsers just have these built in, although they're not necessarily the sexiest or coolest things. And I think what happens when I go back on this link is I go back to the list. So that's just special characters, and you'll notice that the default styling that says we've seen this one, and this is how the web worked 1,000 years no, back in the 90s, is you sort of, oh, it's kind of nice that it's turning purple. And you'll notice that Google does this as well when you're doing Google searches. It actually lets the links change color after you visited them. So let's take a look about links. We look at links. I'll view the source of this guy. Absolute link, href, right? And then /a. This is the clickable text, right? Between the beginning tag and the ending tag. The attributes are on the beginning tag. Another attribute that you can add, and I do it all the time, is target equals blank. And that basically is the way we say, open this up in a new tab. So you'll notice pop up in a new tab. And so that's where that one goes when it pops up. And so you can decide whether or not you want this to go in the same page back or in a new page. And then I got to close the tab to get back. And now I'll go back because that's just a relative link to list.htm. So I can go back and look at the next thing. Let's take a look at how images are represented. So so this is just a paragraph that has an image in it, right? So it's a paragraph, but there's the image. Source equals medium.jpg. If you look in my folder, you see the image right there, medium.png. You don't see the suffix because Mac is trying to hide it from me. And so that's just, you see this space here and here. The image doesn't have any space. We could add some with CSS later, but the paragraph is what's adding that space. Then we have just a regular old paragraph. I'm not supposed to use the center tag. We'll get to the how to center stuff, so that's what that is saying right there. And you can have an image that's right in the middle, so you see where that image is. I think of images, if they're right in the middle of text, they're like a giant character, and so that's how that works. And you can even sort of stick an image as the thing inside of a link. So here's the anchor tag. It's that bit right there, and then the anchor tag body is an image. And so if I click on that,
It's going to go back to list.htm. You'll notice these all go back to list.htm, so I can work on the next thing, right? Tables. Again, you're not supposed to use tables for laying out like blocks of text, which we used to do. We used to do things like use tables to draw borders around things, which we'll see in CSS, but now that's totally verboten, and you're supposed to look at tables in a way that they're, you know, nice and pretty. So let's do a view source here. So let's see, there's our table, our slash table, and a table row. Now let's take a look at the DOM. So apparently I didn't put a T-body. We're supposed to put a T-body in there, and I didn't do it, but this is the DOM. The DOM put it in. That's put in by the parsing, and so clearly I made a little mistake in my HTML because I didn't put a T-body tag, and so that was added by the browser. As it was parsing and reading through this, like, oh, he forgot his T-body, so it just like slapped one in for me. And I think the mistake is this is my header row, and I think that should be like a T-head. So there I go, bad HTML. It's the story of my life. And then I've got the rows, and you'll notice that the DOM is kind of prettier. So sometimes I do this. The DOM is indented nicely. So this isn't really the source code. This is the data that represents this visual, right? It is the thing that you're seeing, but it read this from the file or from the server, parsed it, and produced the document object model. I only say that like 1,000,000 times. Okay, so back we go to the lists. We're making pretty good time. So here's some really bad HTML. I'm going to view source on it, and again you'll see sort of the difference between the document object model. When you're debugging these things, you will have to sometimes view source. Sometimes document object model will be the only way to debug it, and sometimes view source. So this is the one that's got bad stuff, like H1 is uppercase. This paragraph tag is not terminated. This UL tag is uppercase. This LI is not terminated. I don't have double quotes here. So there's a series of mistakes that I've made in this HTML, but it looks pretty good. And you'll notice in the document object model, it's fixed all that. Now, each one is lowercase. The P tag is finished. There are double quotes, meaning the document object model is not just your HTML source code. It's like the sensible, parsed, pretty version of the HTML source code, you know. And so, you know, this UL tag, these LI tags are now done. The UL's lowercase, everything's lowercase. So it's like, I'll take care of your mess. I'll patch up and fix your HTML, and then I'll display it for me and make sense of it. So the document object model is not the same. It is sort of like a sweet, awesome, better version of it. But this is what changes that. So let me just show you something, how I can change the document object model. Let's see. Let me see if I can change this text. I change the document object model. That changes. So I'm actually, but that didn't change the source code here. The source that it was retrieved to produce it, but I can change the document object model. And later in the class, we'll write code that will actually change the document object model. So we'll change this. We'll call this be going to lists yet again. So I can change the document object model. Doop. So you see it changed it. So when we change document object model, what we see in the browser changes, but the source doesn't change. Did I say that enough times? So let's click on this and go back to lists. Okay, so some HTML can be broken so badly so that it doesn't render at all. Whoops, that didn't work so well. I'll do a view source on it, and then I will let you figure out why this doesn't work, why this doesn't show. You take a look at the source, you figure it out. I hope this has been helpful to you. See you on the net.
Hello everybody, and welcome to our lecture on cascading style sheets, CSS. Of course, this follows right on the heels of our HTML lecture. I'm going to use a bunch of examples from webapplicationsforeverybody.com, and you can just bring these up in your browser. I love to place everything that we talk about in the context of the request response cycle, because that's the whole web applications for everybody. You, of course, are out here. You do a click, it sends a request, a HTTP request, maybe talks to a database, gets some stuff back, sends some stuff back. This is the request response cycle right here. And the thing that comes back is HTML. And then that is parsed, put into the document object model. And the thing that you then see, the pixels you see on your screen, are from the document object model. And so that's what we've been doing so far. And so far, in that HTML lecture, we just talked about this, what the format was when you parse the response. So what we're going to talk about today is we're going to talk about, in addition to that, we're going to go and pull another file, a CSS file, CSS, and that is going to inform the document object model, and it's going to change how things look out here. And so, you know, we'll have some CSS in the HTML, but we'll also have some CSS in separate files that make separate request response cycles. So we're going to be putting files like our HTML files in here and our CSS files in here. So we're going to be serving them a little bit, but mostly what we're worried about is sort of the form, how to make the DOM look pretty. And that's sort of what CSS is all about. So in addition, I would like you to install this thing called Web Developer from Chris Pedrick. Chris Pedrick has been doing this a long time. Before there were even developer consoles in browsers. And it's funny that the developer consoles don't do what this does. And I don't use all of its features, but it has some wonderful features for CSS, in particular turning on and off various styles. And so it's a great way to sort of dig through CSS issues in addition to the Web Developer console. And you can do a lot of sort of fine debugging, but there's some real nice stuff with Web Developer. It's just a plugin for your Safari or your Chrome or your Mozilla browser or whatever. So please install that. I recommend it, and some of the assignments actually require it. So like I said in the HTML lecture, the HTML started out with, we were just amazed in 1995 when we could see a page with a gray background and blue links, and it was lists, long lists of links, and the links turned purple, and we would click on a link and another page would come up, and we were like, holy mackerel, this is the future, right? And we were so happy. And our curiosity was piqued. We did interesting things. But, you know, in the 10, 15, almost 20 years since all that, it's become a business. And in business, the look and feel for the average non-nerd user, they don't care that there's a request response cycle. They just want to do a thing, talk to their friends or look up information or whatever. And so the CSS is in the middle of this time frame, that the ability to precisely lay things out and make pages beautiful became super important for the web to take its sort of leap into commercialdom. So if you look at the Yahoo web page, for example, this is just a screenshot I took a while back. They do studies as to how much white space is in between those two pieces. And they'll add a pixel and take away a pixel, and they'll see how their revenue goes. And so these user experiences, these visual looks and feels are highly tuned and highly sort of taken care of. And so CSS needed to be able to precisely have a pixel perfect layout in every browser. And so CSS is a very, very precise thing. HTML has become precise, but we don't want to do our markup and layout in HTML. I showed you tables previously, and in really early versions of HTML, we used tables to create look and feel, and that was never good. So one of the things you can do with the Chris Pedrick Web Developer plugin is you can show a page without CSS. And what you should expect when you see a page without CSS is it's sort of beautiful even without CSS. It's beautiful in a logical and a structure. And so here's my web applications for everybody website, right? It's got cool stuff. It's got these little things that go over there. It's got the little border. The color's gray here, and it's a little lighter gray, and this wraps around, and it looks really awesome, right? Well, turn CSS off, and you should still see a page that you could effectively navigate. It's like going back in time to a simpler time of, okay, I want to see this. This is really a list of links at the end of the day, and there you go, it's a list of links. And the default is I've already clicked on lessons, so lessons is purple now. And here's this video, and if you scroll up and down on this, I mean, it's really fun to go to a website and, turn CSS off and see how good their HTML developers are and how pretty it is. And so it's supposed to be pretty in a simple way. And what's nice about this is it really leads to good accessibility, meaning some people do not see the graphics, they hear the page read to them. And this way, this is how it's read. And the simpler and more beautiful and elegant your HTML is, the easier it is for a person who has reduced visual ability to understand your site. And that is, I remember the joy of hearing from people who were using the web and Gopher in the early days, how they all of a sudden could go anywhere and see anything and do anything in a way that that visually impaired people could never do for like hundreds of thousands of years. And it's joyful. And then what happened is we ended up with this really nasty markup. And then it was like the web was simple and they loved it. And then the web became ugly and nasty and HTML became nasty. And they're like, the world is horrible because now you go to all these cool websites, but I can't go to these cool websites because I'm visually impaired. And now we're back. We're back to that. We're back to beautiful HTML, simple HTML, and then beautiful web pages, and CSS is the matter. Okay, I think I've done enough advertising for CSS and accessibility and beautiful HTML. So ultimately, if you look at how this thing is assembled in your browser, there is an HTML page that is pulled down, and then there is CSS, sort of both inside the document. Sometimes there's CSS in the document. If you look at this, not that it matters, there's a little bit of CSS in that document, and then a whole bunch of other CSS that brings all the beauty to this. Sometimes it even takes some JavaScript and whatever. And so we understand that the HTML does not have the beauty in it. The beauty comes from the CSS. And that is part of what we try to do, is learn CSS. So if you're going to be like a coder and you're not going to be a graphic designer, you still need to know enough CSS so that you don't write horrible HTML, so that you know what a really good CSS developer is capable of doing on your behalf. And on large projects, including like Sakai project, which is an open source learning management system, this allows separation of concerns. And you can have people that specialize in the back end and the HTML, and then a web designer can, the web designer, so if you think of the developer, usually there's a back end, and then they generate, from the back end, they generate the HTML, and then the designer will build the CSS. The designer will often have skill enough to sort of tweak the HTML if the developer built bad HTML. So they kind of meet in the middle at the HTML, with the developer mostly being responsible for building the back-end developer. And then the front-end designer can then tweak the HTML a little and then tweak the CSS. And so the HTML is where the back-end developer and the front-end developer come together, but it means that you can have lots of people working, and you can develop highly specialized skill sets in larger projects. I know that my skill set is in this side. I am not skilled in this side, right? I can clunk my way through CSS, and everything that you'll see is my CSS, and you'll be like, whoa, that's not very good. And if it even looks pretty of mine, I'd probably use Bootstrap, and I cheated and found a CSS framework, and I didn't build it, I just did it. Now, there are people who are smart enough to build Bootstrap. They can build such gorgeous websites, and my job is to build beautiful HTML that then they can add CSS to and make it super gorgeous. So the CSS basic syntax is different than HTML, right? HTML is less thans and greater than. CSS has curly braces. I don't really know who invented the first. I should find that out and go videotape that person. But it has curly braces and semicolons, so it kind of looks like a little bit of C. And it's really a set of rules. And it's not sequential, although the order does matter, because what comes later has more importance than what comes earlier in CSS. But it's not like code that gets run. And so the anatomy of a CSS rule is that there is some kind of a selector. And in this case, the simplest selector is the tag that we want to affect. We want to affect the body tag. Now, there's only one body tag, but you could have a P for a P tag and say, I would like to do this to all P tags. And so it's implicit, kind of like SQL, in that a body tag means for all body tags. There's an implicit loop for the whole document. and we'll see how to reduce that later to it so it's not always the whole document. But for now, a tag means a tag there by itself means every tag in this document. And then there's a series of rules, and so this is really when to apply. This is sort of what aspect, and there's a whole list of aspects that you can have, and then what you want to do. I want to make the font size 100%, I want to use Arial, and then sans serif, etc., etc., etc. Holy mackerel, my little pen is undoing itself. And so then these end in a semicolon, and you can have a bunch of these, right? You can have just one, you can have more, but that's the basic idea. Is a CSS rule is go find a part of this document and paint it. I like to think of this as like, go find a thing and then run a paintbrush over top of it that is this paintbrush. That is the paintbrush that you go select a piece of the document and then paint it yellow or paint it bold or whatever. That's kind of how I think about it. Now, I'll admit I am just I'm really a very weak CSS developer, and I need a cheat sheet. And if I'm going to do CSS, having this even a single page cheat sheet is super helpful for me, just because I don't use it all the time. And so the attributes like background color and the border dash bottom, you know, for me, they're all very self-explanatory. They're really easy to understand, or if you don't understand them, you just Google and you go Stack Overflow. But like for me, I'm like, is it border bottom or bottom border? I just can't remember that stuff, and so I just have to have a cheat sheet whenever I work. And this is one cheat sheet that I happen to like. And these are the kind of properties that we're going to be playing with. Color, the background color, how to align it vertically, how to align it horizontally, padding, which is space on the sides, etc., etc., etc. So there's just tons of CSS properties, and there's tons of great documentation on each of these CSS properties with little samples all over the place. And I have my own samples as well that I'll do some recordings and walk you through like line by line on my sample code as well. But this is the kind of stuff that we're going to play with in CSS. So up next, we're going to talk about how we connect CSS and HTML together. So welcome back. Now we're going to talk about how you use CSS within HTML, how you take these CSS rules and apply them to the various parts of HTML. And there are three basic ways that we do this. One is we take an HTML tag and use the style attribute and just put those little CSS key value, CSS settings right there, very close. The other thing is you can put it in the background of the HTML document, usually in the head area. And the other, probably most common thing, especially when the styles get large, is an external style sheet that's a separately loaded file with a separate request response cycle. So we'll start with sort of the simplest but sort of least used of these things. And that is, like I said, you can put a style attribute on any tag. And you say any attribute, you say it's got a double quote and a bunch of stuff and another double quote. And in there is a series of CSS rules that are basically CSS setting like border style, colon, and then the border style setting that you want. And so in here I'm saying I would like a solid border, I would like it red, and I'd like it to be 5 pixels. And that effectively determines how that particular thing gets painted, right? In this particular one, I said font family monospace for that particular paragraph. So this paragraph is painted with a font family monospace. And so you can just put these things here. I put on the body tag, I want an Arial sans serif font. So the whole body is not Times New Roman, except for the fact that this particular one is monospace. And so these two tags are rendering opinions about what the font's supposed to be. But because this one is closer, the monospace wins here, but the Arial wins everywhere else because none of these other tags render an opinion. And so that's kind of the cascading bit, meaning the closer it is, the more priority that it has, unless of course they put important up here. And important is something we'll talk about later. You can make the farther away override the local, but it's not something you want to use too much. If you're using important, that's a trouble. But don't worry about important right now. Just imagine cascading means the closer, the higher priority. Closer to the tag the statement of CSS is, then the higher priority that it is. So another place that you can put the CSS is right there in the header, right? So instead of putting it on a tag, we can use a style tag in the header. And so here we have the header of the document, right? The head, The body starts down here. And up here, we're going to set a set of rules. And now we're using the thing where we have to say which thing, a tag it goes to. So now I can say the body tag, even though there's only one body tag. We want a font family Arial sans serif. And because they're all inheriting from the body tag, then all the paragraphs inherit from this, and the headers inherit, etc., etc. So it's like body on down in this particular case. The header 1, which is this, is blue. And paragraphs are supposed to have a solid border, red, 5 pixels. And so border style, border color, etc. And that means that each of the 2 paragraphs here are away you go. And I'm going to dig into the anchor tag, and here's my little anchor tag. And I'm telling the anchor tag that I would like to have a green font, and I would like no underline. The default is to underline them. If you look at links, they're always underlined. I'm overriding that. And then I want the background color of that text to be light gray. And so this is a set of rules. All that HTML is down here, lower down, and there are no style tags. There are no style attributes on the tags because we have basically said for all paragraph tags, for all anchor tags, for all H1 tags, and for all body tags, and we put it up here in the top of the document. Now the problem is most websites have multiple pages, and this gets really frustrating after a while. So you really want to pull some of those widely used or repeated things out into a file and include them. And all we do is take pretty much that same set of CSS rules and we put them into a file. And in this case, we'll put them in the same file, same directory, same folder as the HTML. Although you can pull these things off of a website if you want. So http:// or whatever. But you put a link in here and tell it's a CSS. And it's going to be a style sheet, and then you give it an href, which is then going to pull this file in and sort of expand it as if it were right there in the middle of a style tag. And so it knows it's a CSS, and it pulls it in. So that's how you change your HTML. So now if we take a look at the next example, we see that in this next example, we've got a link, right? And down here, we've got no style. Ignore this little thing. That's how we're putting this little, don't ignore that page. But in the real stuff here, we've got this. We've taken our, we got our pre-tag. We've moved it in. We've got some things here. We got all that stuff that we've done, right? And if you look, here is that rules.css file. Rules has all that same stuff. H1, border color, a tag, all that stuff that we put in the head now is sitting in this rules file, and we're just pulling it in right here in one fell swoop, and it accomplishes the exact same thing. Okay? And so this, including in a separate file, is by far a superior way to do it than putting it in the head tag. So, but sometimes you have to change 2 things and you put them in the head tag. And it's up, you use all 3 of these ultimately, but generally you tend to start with a large amount of CSS in a file, and then you tweak in the head, and you might tweak on a tag here and there. And that's kind of how these 3 things tend to work together. And the whole cascading thing works out well. You can put the link first and then style tag second, and then it kind of overrides some of the stuff that are in the linked, and then you can have something on a tag which overrides the stuff that's in the head. Unless, of course, it says important. So, as the world went from hacking look and feel in HTML to finely tuning look and feel in CSS, all these tags, paragraph, H1, body, they all had default styles that had kind of evolved, and links and all that stuff that evolved, and a lot of pages depended on those default styles working. And so they couldn't say, welcome to CSS, and now all the styles, a paragraph that's unstyled will look terrible. Not that they look great. And so we couldn't take the paragraph tag. Everything had a style. That's the problem. All the existing tags had something on them. So they had to make new tags, and the new tags that they made are the span and the div tags. The key to the span and the div tags is span is an inline tag that has no styling associated with it, no default styling. It is defined as having no styling, and the div tag is a tag that has no styling associated with it, but it's a block tag. And so we sort of use these to sort of mark text, but don't inherit, without inheriting any styling from some long ago 1993-94 defaults. And so the span tag is span tag here. That's kind of broke over a line. The span tag has no styling except that styling which you add. In this case, I'm adding it with a style attribute. And the same thing is true for a div tag, right? The div tag And also divs can be within divs. So this is a nested div, right? There's an outer div and an inner div. And basically you know that styling, the div has no style whatsoever, right? The span has no style whatsoever. So if you just put something in a span tag and you don't do any, you don't sort of render an opinion about what it looks like, the span doesn't change it. It just is, it inherits from whatever else is there. And so if we take a look at this, right? So here we have a P tag with a green border, 1 pixel border solid. Now, the interesting thing is you say, well, did the paragraph tag have styling? It turns out it does. It has some margin and padding to make it look better, right? And so the paragraph tag is not an unstyled tag. It is expected to create blank space around itself. And so, yeah, we got, so the paragraph tag has a default style. It's supposed to have a default style. But then if you look at the div tags that we've got here, like this div tag, this div tag, remember, goes all the way down to here. This div tag, I just put a blue around so you kind of know what's going on, right? So this blue goes from here to here. But you can see right away that the div tags have no padding or margin or sort of little white space to make them look prettier. And that's okay, you've got to do that. You've got to add the padding and the white space. They just start with nothing. It's just a block, right? And the span tag, this one here, changed it green because we put a style color equals green right there. And okay, so we did that. And the div tag, and you'll notice, interestingly, these, because the divs I'm using end up with a 1 pixel border as their style, meaning they started with nothing. You can even see that if you look really close, it's impossible, but you can zoom in. This orange border, the blue border takes up space, and then the orange border's on inside of it, and that's 1 pixel wide. So I'm adding to these through the style attribute, I'm adding CSS to them, but they start with absolutely nothing, and they kind of look ugly when you just like put something in a div, it's like right next to each other, because they didn't want anything. And again, they're nested, and there's reasons, because we'll use divs to say, this is the main body, and then there's divs within the main body, and then this is the navigation, and this is the footer, etc., etc., etc. And so we have, divs are ways to describe blocks without adding CSS styling by default, and it's, as such, letting you define all the CSS for these things. So these are cool. They're like the non-tags, the untags, the tags that don't cause anything to happen but let you cause everything to happen. So they're really important. They're really important. So the next thing I want to talk about is making a sort of finer selection of which tags that you want to apply a rule to, right? A rule to. And so if we look at this tag right here, this is the body tag, and that basically says I want everything from body to /body, then everything inherits. So unless it's overridden, I want Arial sans serif to happen. Okay? And I can do that with a paragraph tag, but I want to show you this other thing. So there's a way to mark a tag. Let's find this one. Where's first? First right there. So there's this ID attribute. An ID attribute is an attribute that was added kind of specifically for CSS as well. And so you can only mark 1 tag per document with an ID. And then there's this class tag, and you can mark as many tags as you want in the document with a class tag. And the idea is like ID tags are for chunks, like main page, like left navigation, top navigation, or something that's only going to appear once on the page. And so if you want to sort, in effect, what #first means is look through the whole document, find a tag. Where's div ID equals first? Where's that stop? Div, right there, right there. Find the tag that's got an ID of first, and then paint it with those rules. The class can happen more than once, but more space, let's see, class is more space here, that's there, and so that basically says, let's change clear and change color here. More space says look through all the document and find all the class. There's that paragraph. Ooh, do I not close that paragraph? Oops, mistake on my HTML. Here, yeah, so that basically says change the margin left. That means shove this in, and change the margin right and shove it in. So we'll see all these things. and loud. And then you can also see a situation where when you put classes on, you can have more than one. And so this basically will respond both to the shout and to the loud class. Okay, so let's take a look at what this page looks like. So here we go. It's a little busy. So if we take a look at first, it grabs this tag here, the div tag is first, right? And then if we look at like more space, this more space is affecting this one, and it's shoving it in both on the left and the right, and that's because it's this paragraph more space. Okay, shout, let's find the shout ones. Well, we can see them right here. They're all the loud ones. So that is red. No, that's shout and loud. Oh, here's one that's shout. Oh, entire has been shouted. And all has been shouted. So you'll notice these guys are lowercase, but shout is a text transform to uppercase. So you can even change the case of things. And then in third, for example, where's third at? Third says within, so this says find the third div, which is right there, and find all the p tags within the third div, this p tag and this p tag, and then apply a background color yellow to all those, which leads to this right here. Okay? And so # means find ID and apply, dot means find class and apply. You can have multiple classes, right? Pull in the definitions from two classes, shout space load, go find the whatever's in CSS. And then you can kind of have hierarchical things, and this is quite useful because you don't have to get special. It saves you putting classes on. It saves you from putting classes on all the paragraph tags here. You don't have to do anything, but you're not affecting the paragraph tags outside here. You're only affecting the paragraph. I think of this as go find third and the paragraph tags within third, and then do something to them. And that way, otherwise you'd be making more classes than you need to be. And so this is a very well-liked technique for really fine-tuning your selection, your selector for CSS to touch only the things that you want to touch. So up next, we'll talk about images and colors and fonts and a few other things. So welcome back. Now we're going to talk about making our stuff look a little prettier with images and how we can play with images, colors, and fonts. So CSS and images are a lot of fun. We can fool around with them. We can move them around. Actually, this for me years ago was the thing that in 1994 that made me fall in love with the World Wide Web. So what made me fall in love with the World Wide Web was the ability to take a picture of me, and I love pictures of me, and then float it to the right, and then I put a little border around here. And so that's what I've done with CSS. So let's take a look at how I've done that. So if you look in line here, the navigation, which I'll show you when I go through the code walkthrough how the navigation works. But at this point, at the end of the navigation is right here. And I put this image in. So if you were to watch this inline, the image is right there. But what I do is, when I say float, that actually, and there's other things that we'll see when we start looking at fixed and absolute positions, you can pull it out of the regular stream. And so this is like pulled out of here. It's as if it didn't exist. And it floats to the right, but then it's vertically aligned. So the next thing you see is this header 1. This header 1 CSS, oh, there's a typo there. I got to fix that. So I'll pretend that was an H1 there, but that's okay. So this header at Quarks mode, I should run this all through the validator to make sure I'm okay. But okay, so the top box of this CSS and images H1 is right here, and then this floats over, but then it top aligns. Now you can change this alignment if you like, but it top aligns here, and then it actually looks at the width, in this case the width of the picture, but you can also control the width up here in the CSS, and then it carves out this space, and then I do a margin of 1em. And so on M, you sort of sometimes wish they would put default formatting on, but then they kind of tend not to put default formatting on, because if they did, then you have to turn that off. And so I wanted some white space, and so I had to put some white space around it. And so I said I'd like a margin of 1em, and so that puts a little bit of space here and here and actually here as well. So you see that this lines up over there. And then that talks about what is a 1M. So 1M, I could have said 5 pixels, 5px, and that would have been fine. But 1M is basically the width of the letter M, roughly. It's sort of, it is a width that changes with the size and nature of the font. I think of it as the width of an M, and I think that might be a soft definition of it, but I don't think it's a precise definition of it. But that's what I did. So float right hoists it and sends it over here, and then shoves this over so that this text is now, it reserves this space so the text is wrapped, basically. And then I held out some space just for prettiness, right? And so that's like CSS is making it look pretty. Now, what happens here is sometimes you want to basically force, after this float has happened, something back to the left margin. And there's this clear equals all that says clear any floats is what it's really saying. And so it means that even though this, if it wasn't for clear equals all, this next paragraph would have been kind of up in here. And then maybe it would have wrapped if it was long enough. And when you play with this, you can resize it and see how the wrapping changes. But no matter what the size is, after the BR clear equals all, this is going to format back to the left nav, right? So that clears that hanging wrap, that sort of, but you don't have to. You could not do this, and then it would wrap and wrap and wrap, and then it would get longer and it would continue on. But if you want control over that, you can with the BR clear equals all. And of course, you can have images right in line, and this is just from the HTML bit here. There's nothing fancy CSS here. Images kind of are like big characters. I sized that one so it sort of fit nicely, and you could even make this a clickable link. But that's really just, this part here is just HTML, not CSS. But I could have, if I wanted to, change the width and the height of this. That'd be kind of fun. Make this guy be like the width of an M, and then you'd see it more like a character. So there's a bunch of colors, and the colors have to do with, there's the simple thing for us simple folks. You know, we just put in things like red and green and stuff like that, and especially if you're doing a developer and you're just trying to get basic stuff working, I often use colors in my testing. That, like, put the border red. I do that all the time to say, where was that div at anyway? So I'll throw a 1 pixel border around it, red border, like, oh, that's where it is. Although the Chris Pedrick plugin has a thing where it puts 1 pixel borders around everything for you automatically. But whatever. These are not necessarily most graphically beautiful colors, even though I like them because they're super primary in terms of primary colors and strong. You'll see that I kind of use those colors in my slides a lot because I'm not a graphic artist, of course. I just like, oh, the greenest I can be is good. So there's 16 official colors, and they're here. Once you get a little more sophisticated, you can use precise colors from I think this is a, I don't know, 32-bit. Yeah. So this precise colors are the ones that start with £. And so £, and these are hexadecimal numbers. These two numbers are effectively 0 through 255, but they're in hex. So hex is like A, B, C, D, E, F are actually numbers. 0 through 9, this is actually 10, 11, 12, 13, this is 15. And so E is bigger than 9, and F is bigger than E. But basically these are 0 through 256, that's a three tuple of 0 through 256 numbers. And so the more red you put in, the higher this is, the more green you put in, the higher that is, and the more blue you put in, the higher that is. So RGB, red, green, blue. And if you're playing with like a slider inside your UI, you might be changing this, but you're just changing these numbers ultimately. And so you can find these things. You know, so white is all Fs, and so if you turn it all on, it's white. If you turn it all off, it's black. The absence color is black. Red, green, so you turn, that's max, max, and max, and so you can make sort of a pure red, pure green, and pure blue. Picking these advanced colors is sort of way beyond my ability as a graphic artist, and people will pick colors. There are sites that help you pick palettes for your pages, etc., etc., etc. There is also a, sometimes these colors can have a transparency, and there's a fourth set of 2 numbers that have to do with how transparent the color might be. So fonts are also important. The default font is a Times Roman because that's what computers had in 1994. And I think they're ugly, especially on screens. They're not so bad on print, but they're ugly on screens. And so I tend to want a sans serif font. It's too bad that and maybe they have changed on some browsers default for sans serif. I just change it to sans serif all the time I want. Now if you look at fonts, the font family is kind of a special tag in that you ask it a set of fonts. And what you're really doing is you're setting a priority. And the problem is depending on whether you're on Windows or Mac or which version of Windows or which browser or what fonts they've had installed, fonts might not be there. And so what you basically do is you basically say, okay, I would like this. I think this is a Microsoft font. And if that font's not there, then I would like this font. And I think that might be also a Microsoft font. And if that font's not there, then there's Arial. See how much I know about graphic arts? I have no idea. I think this might be a Mac font. And if that font doesn't work, default into the fallback font sans serif. And there is always going to be a serif font, Times New Roman like, sans serif, Arial like, monospace, which is courier like, cursive and fantasy, which are whatever. And so all browsers are supposed to have those fallback fonts. And so you tend to see them here at the very end. And so when you see me, I usually will say Arial sans serif or something like that just to get sans serif. Although it's quite common, the more sophisticated a page is, the more likely. And the other thing that's increasingly the case is people are downloading fonts and having special beautiful web fonts, and then they download them and then they put that font in here, but then they probably still have fallback fonts. So font family is kind of a weird and unique and glorious thing that leads to some really gorgeous web pages because so much graphic and arts work is going into making web pages beautiful, and we're going way beyond the operating system installed fonts and having pages that download their own fonts. Things that you can do is set the things to bold, italic, text decoration. Remember, links have underlines and we can turn them on or off. Font sizes are kind of troublesome in that you can set them to pixels, but then you're in danger if you get to a certain kind of a screen size or people start zooming the screen and stuff. And so you can tend to use these relative ones, but they're not as guaranteed as you might like them to be. And so just these are a little bit tricky. Absolute font sizes are a little bit dangerous. I tend to just go like, here's my font, here's the one that's a little larger, here's a little smaller if I need that. So most of the time I'm tending to do things that are like smaller. If I'm putting like a copyright statement and I don't want to distract from the main page, I'll just make it a little small. I'll say, okay, make this small or extra small, and what if it doesn't turn out to be that much smaller? It doesn't matter. I'm just kind of trying to so I'm not an expert in how to use those. I tend to use them as simply as I possibly can because they're not as predictable as it would be nice if they were. So links were a big part of the early web, and it's called hypertext markup language, hypertext transport layer, hypertext. And so links got really special treatment. They used to be blue before you clicked on them and purple after you clicked on them. The blue was to jump out at you and say, please click me. And the purple was to say, I've been there, because a lot of what you did in the early web is you wandered from place to place to place to places like, oh, I found a new thing. Let me explore this. And so you're always like exploring by clicking links. Once we got to the point where people assumed the web, these links didn't need to be blue and garish colors to teach us these things because people just clicked on everything. And so it became more important to make things pretty. So we have a lot of control as to how we style links. We can say the A tag, we've already colored an A tag with just the A at the top. You can basically say an unvisited link is supposed to have the color black. After the visit, it's supposed to be gray. While you're hovering over top of it, it's supposed to have text decoration and down there and be black, white with a background of navy. And then active is not so heavily used. It's once you've clicked on the link while the page is loaded. So it's a way to kind of, maybe disable it or turn it a color so people think, oh, I better wait until this next page loads. And so when I do the recording, you'll see this. It's a lot easier to see this dynamically. And so there's a whole bunch more samples that I have, and I'll record some walkthroughs of every single one of the samples. And so you can take a look at that at Web Applications for Everybody or in the recordings. So this has been a zoom through CSS. You know, CSS is quite the art and science, and it's evolutionary. I mean, people are specialize in this. They're very good at it. It's a modern form of graphic arts. The basics are there, and I think every programmer who does anything on the web should know the basics of HTML. You know, they keep moving things better with things like nav tags and Bootstrap, etc. And while there will always be like edgy new things in CSS, and so sometimes you'll see CSS with like these Moz fields, which are for Mozilla for the Firefox, but people are always pushing that boundary. And before you couldn't put rounded corners on things, but then the browsers added extensions to put rounded corners on things, and then everybody kind of agreed on that. So CSS is kind of always going to get better and better and better, because for the mobile and desktop, they really want to create as beautiful experience as possible and use standards wherever possible. And so the basics are there. You can do so many wonderful things, especially if you pull in something like a Bootstrap that just kind of cleans up the rough edges of HTML and makes it generally pretty and takes a lot of responsibility off of you. But you can certainly make a lifetime study of CSS if you like. So I hope you found this useful. I will see you on the net. Hello and welcome to Web Applications for Everybody. We are taking a look today at cascading style sheets. You can download the source code and unzip it on your computer if you like, or you can browse this code and just play with it in the browser, because it's all static content, so it's just as easy to play with it in the browser. And of course, we're going to want to take a look at this in the developer console. It just makes a lot more sense to get into this, and so here we go. We're taking a look at CSS. There's a couple of ways to do this. We can see here, we can see the style attribute. Style color equals blue, and there's all kinds of various CSS parameters. Color is the parameter and blue is one of the values, and you gotta look all these things up. One of the nice things that we can see is we can see over here, as we move between elements in the document object model, we can see what the CSS values are. And so Arial Sans, like for example, this is cascading. The body on here is Arial or sans serif, and that means an Arial font if we can get it. Sans serif is a fallback font. And so that this H1, this little bit right here, this H1 is being colored. This is ours. Browsers have their own default, so display block, font size 2EM, which is twice as big as the rest of the font, etc., etc. And so this came from the browser, and then this came from the style sheet. So this is cascading, and the bottom ones here are this is the most important one because this is the one we said that's closest, and that's how the cascading works. Yeah, we already saw that. We already saw that. And then the cascading is, again, we take a look at this little guy here, right here, and so the closest one is we want a monospace font family, but the body said the font family is Arial and sans serif, but this one has been overridden, and we can kind of see that, and that's why this particular text is monospace. Another thing we can do is we put border style. Now when I'm working with this stuff, I tend to remember border a lot because it's a good way for you to mark something out and say, what am I doing here? And we'll see, like when we're moving text around, border, solid border, a red border, and a 5-pixel border. And so that's what we see. And you can also see that there's some extra padding around there as well, or some extra margin. And margin top, that's another one. I'll scroll this up a bit. Margin top throws 5 M's of space above the text, and so this is a normal paragraph. But we got 5 extra M's. Now what's an M? M is the height of a character in the current font, and so M's is a really convenient measure. There's M's and pixels and percent. So margin before, that's 1 M over here. The paragraph already has an M. Margin before, and then, well, hang on, come down here. Down to here, we've added the margin top. So this margin top overrode the margin top that was part of the paragraph tag automatically. So that's these style rules. So let's keep on going. while this is technically possible, this would really be overwhelming to put a style on every tag. And so one of the things we tend to do is we want to put style rules that are generic. So we'll say we would like the body tag, and this is a style rule, this is the selector, body, and then font family. And again, font family works as please give me the Arial font, and if that's not available, give me sans serif font. Curly brace, H1 tags. When go through the whole document and paint H1 tags blue, go through the whole document, find every paragraph tag, set the border style to solid, border color to red, 5 pixels. So you see that every paragraph, and we're going to change our anchor tags to have green and have no text decoration because they're defaulted to have underscore, and we're going to make the background color light gray. Why? Just so we see it, so you can see that particular thing up there. And then if you look down into the text here, we have paragraph tags and an anchor tag, and no style equals down here. So what we've done, ignore that little part there, that's what puts this little thing in the corner, so that's not what we're talking about. We put no style tags whatsoever, and we put all the style tags up here. But now we've also done something that all the paragraphs have to have the same style, which sometimes is what you want, and sometimes it's not what you want. Now what happens again now, if you have multiple pages, as we have here, it gets a little tiresome to put this text in every page. And so what's really common instead, so now we have the same basic rough paragraph stuff here, nothing in here. We have a pre-tag, of course. We have a paragraph tag. There's no style equals on these things, but up in the head we have one line right here that basically says, let's take a look at this style sheet. And if we were to look at the style sheet.css, it is in the same folder, rules.css. It's in the same folder as that HTML file, and it's exactly the stuff we had there. It's just a set of selectors and then a select of key values we want, color blue, border style, border color, etc., etc., etc. And so it really is the same as what we showed before, except now that we have to put this into every file, and you'll see we'll put this now from now on in every one that I'm looking at. And so, but now our problem is that we've done something with this to do all the headers, right? All H1s, all paragraphs, but we need better ways to mark text. And so, we have these tags, and these tags that we use just to put handles on. In the old days, like this paragraph tag has this border. See that has the margin up there. I mean, it has the border, but it has this 1em margin. That's that space that you're seeing that makes paragraphs look good. I mean, it's not a bad thing. And so if you look at that, we have all these colors. We've got the strong tag. By default, the thing uses a serif font. I don't like that. So let's get down to here, and this. Well, let's just look at it here. The span tag, inspect element, right there. Okay. So the first thing is the span tag is an inline tag that has no styling. The problem is before CSS, which is a long time ago, all these tags had default styling. But the span tag is an inline tag with absolutely no styling whatsoever. And then the div tag is a block tag that has no styling whatsoever, and it can be nested. So it's kind of like a paragraph tag, but it has no styling whatsoever. Now I've added a 1-pixel style, and you'll see that these div tags don't have any extra space, like the paragraph tags came with space. Now some people would go and turn off the space on a paragraph tag, and there's even CSS files that you can to take all the default styling off tags. But you'll notice these divs don't have any space. They're really kind of a block. When I put these pixel on, you see the border. If you look really close, you'll see that there's a 1-pixel blue line and a 1-pixel orange or sienna line right there. But the divs can be nested, and they don't themselves start. So you'll notice that here they don't start with any kind of formatting that comes from the browser, whereas if we look at paragraphs, there is formatting that comes from the browser. And so the div tag the div tag and span tag are just our ways to put handles around blocks of text or chunks of text and then style those. But then we still have to figure out how to grab our handles and make it so that our styling doesn't just touch one thing. And so here I've got a couple of things. I've got the body tag, and I'm setting font family. You'll see me do this all the time. And now I have a pound sign, and this says go find all the tags named body. This says go find all the tags with a attribute of first, ID equals first, ID equals second, and then class and shout. So if we take a look at the text, there is the notion of an ID tag. Okay, an ID tag that is unique within the document. So we're going to call this div first, we're going to call this div second and this div third, and they correspond to first, second, and third. Okay, and so first is first is monospace. What is it? First is monospace. Second is green. So everything that's in this block that's second has been green. And then, but you can only have one ID named first. But class you can have all over the place. So we can have, we can put the more space class on a couple of different tags. So this tag, more space, all more space does is shove it in from the left and the right, margin left and margin right. So it kind of pushes this in. And so you can put this on here, you can put it another place, and so the more space pulls in something here. So here's another paragraph that's got more space. That one has more space. This one has more space. See that one? And so you can put more space on as many times as you like, and then div third. Right. And so the hierarchical section means, in this case, this one's a little bit, and loud is red, so where's loud at? So let's inspect that one. Inspect element. Yeah, so that's the loud is not only red, but it's also forced uppercase, text transformed to uppercase. Shouting and loud, and you can have more than one class on on a tag, and then you can be even more precise with your selection. This is basically, this says find a third ID and then only paragraphs within that tag third make their background color yellow. And so that means that background color yellow does not apply to this tag, it doesn't apply to this paragraph, doesn't apply to this paragraph, but when you see div ID third, we have selected this paragraph and this paragraph, and they have a background color of yellow. So continuing on, let's take a look at a simple navigation bar. Now, there's this nav tag that's an HTML5 thing, and if you look at most navigation on pages, let's go to the next one. They're pretty and they got colors and they move around and stuff. But what we want to be careful when we build our HTML for these kinds of things to make them very, very simple. And so what I've got is a navigation is usually, we describe it, we use a nav tag, which is a block tag that says, hey, this is our navigation, useful for screen readers, etc. And then we're going to say we're going to have a list of two links, and so that's what we're doing: unsigned list, unordered list, and a list element that's just no paragraph here, just an include, just a anchor tag, and we're going to put a class equals back and class equals forward, so we can style these two things differently in the future. And so this is what this looks like with no CSS whatsoever. And so this is a nice, elegant, clear HTML. And so if you were just looking at this HTML, like a screen reader might be looking at, you can see what this really intends to mean. Now, then what we do is we add a little bit of HTML to this. And so for now, we're just not going to bother, but in navbar.css is the HTML or the CSS that makes this pretty. And so there's a whole bunch of stuff, and we'll come back and take a look at that in a second. Okay, and so there's our styled nav bar. So I'll come back in another video and pick up right here. So welcome back. Now we're going to take a look at some more examples. We're not going to the one thing we're not going to look at is exactly how this navigation bar works, at least until a little bit later. So the next thing we're going to take a look at is how fonts work. And there's a couple of ways that you can put fonts into a file. There are default fonts that every browser is required to produce, like serif, sans serif, monospace, cursive, and fantasy. And so you don't exactly know what's going on, but they're often used as fallback fonts. And so you can have those. There are any font that is on the system, like Arial or Helvetica. And so if you're going to use Arial, not all systems have Arial, although most of them do these days. And you have to have more than one font. Now, another thing that's really common these days is to include a font somehow. You find out about a font, and here's a Lotto font, and you go look it up on the web, and you find, oh, include this. And so I included this link because I found this really cool font, Lotto. And this extends the browser. The browser then learns about this font, it downloads the font, caches them, and keeps them in the browser. And then I can make a font that's Lotto, but just in case I'm off the internet, and I can't download this thing, I have sans serif as a fallback for Lotto. So Lotto is a fancy font, etc., etc. So there's Arial and built-in fonts, etc., etc. And so that's how fonts work. Colors. There's a lot of cool stuff about colors. There's a couple different things. We'll ignore the nav for the moment. I'm just using span tags here. There's some default colors in the earliest of browsers. These days we have all these fancy ones, and you can go look these up and you just Google for HTML colors. And there's a bunch of names, and then they're consistent across browsers. But there's like 12 or so really solid names that are in all browsers since the beginning of time. But more modern browsers have a better palette of colors. Although really good graphic artists want to have much better control of colors. And so this is, the pound sign says that this is a hexadecimal number, and it's got 2 digits. Hex means they go all the way up to F. So F is A through F are numbers. 8B is the red level, 45 is the green level, and 13 is the blue level. And so this is a brownish color. And then there's what's called web safe colors, where you just have, this ends up being 88, 44, 11. But it sort of reduces the number of potential colors if you were mixing colors from various sources. And then in HTML5, you can see this color picker when you have a form, which we'll talk about in a bit. It's a color form for modern browsers, and then you can pop up with this button, a color picker, and I've got a little thing to print out what the color would be. And so it just, when I pick the green, it basically puts 00FF, that's red, green, and blue. It puts that into this thing, which then the program could use. Could read this, or JavaScript could read it, or server code could read it. But right now we're just kind of playing with the picker, and we pick a different color. And so that magenta is all the red, none of the green, and all of the blue. And orange is all the red, some of the green, and none of the blue. So those are all just really strong colors. And so that's what's called an HTML color picker. Anchor tags. In the old days, anchor tags were kind of funky. They were blue if you hadn't yet visited them, and they were purple if you had visited them. And so this one I've obviously clicked on. And so we have a whole series of styling mechanisms that we can have. If we take a look at these, I have put these all inside of an ID tag of cool. So this is basically saying find the ID tag of cool and then style anchor tags to make them font weight bold. So let's take a look here. So I got one paragraph that has this one here, and then I have a paragraph with an ID tag of cool, and that's basically so I don't have to style. Usually you wouldn't say I'm